Welcome to Touileb. To the nearest exit and gather in front of editorial. Thank you for your attention.
All right. Hi, everyone. Good morning. My name is Samia Touileb, and I am the, let's say, moderator today. I'm very, very happy to see many of you today on our little bit special UiB AI seminar on aligning AI with human values. It's a bit different today. We're having actually a very long seminar. It's different from what we usually do, which is just 2 hours. Today we have 6 or I don't know how many hours, Doug? I haven't counted, but we have many hours. This is important because these AI systems now actually are becoming more and more part of our everyday life. They are being integrated everywhere. And it's very important that we ensure that they actually align with our human values and long-term goals. This is what we're going to mostly talk about today. And we believe that this is not something that only has an impact on research, but it also has impact on society at large. So, there, yes, this is us. Dag from UiB AI, and me on the other side. Something different with this seminar also is that it's actually sponsored by UiB AI, but also Bergen's Universitetsfond, who gave me money to organize this. So if any people from there are looking at us, thank you again for sponsoring this. So this is us. If you need anything or have any questions, just approach any of us. We'll be here all day long. All right. So what is actually AI alignment? I tried to actually find a definition of it. I tried to look at many research papers, and I found one that I think kind of summarizes all the papers that I've read. And it says that AI alignment focuses on guiding AI systems to achieve goals, preferences, values, societal norms, and ethical standards set by individuals or groups. And an AI system is aligned when it successfully advances these intended objectives. And this is particularly challenging, of course, whenever we have AI systems that are more autonomous and capable. So if we think that we have humans on one side, and then we have an AI system on the other side, what alignment is trying to do is basically just kind of bridge kind of a gap, let's say, between them. There is a lot of research that have tried to identify what kind of alignment should we go for. How should we align these systems? So the first one is that you will give instructions to the AI systems. For example, you ask the agent to do what I would instruct it to do. Another way to do it is by following intentions. And here I ask the AI to do what I intend it to do. And then we have preferences. And here I would ask the AI, or let's call them agents, to do what my behavior reveals I prefer. And then we have also desire. And here again, the agent would try to do what I would think is rational and informed. And then we have interest. And here again, the AI will try to solve what I am interested in. Sorry, I have to cough. I'm back. And then values. And here the agent is actually trying to do what is morally ought to be, or ought to be done, basically. And the last one is actually the one that is most researched, because it kind of is believed to be the best way of aligning systems. But with whom should we align? And which values to be aligned with? So there are different groups, all of us, and we all might not agree on what are ethical values or societal norms or what we believe is right or not. Especially if we think at a larger scale, people in Norway might not agree with people from, I don't know, South Africa, for example. They might agree on some aspects, but maybe disagree on some other aspects. So how can we actually define whom to align with and which values to be aligned with? So don't despair. You're going to learn a lot today, and hopefully you will understand how we can do that. So today we will explore we will explore some of the technical challenges of ensuring AI systems are aligned with human values. And we will also look at the broader ethical, societal, and political implications. So we will not just talk about technicalities, but we will look at it from a bigger perspective. And we have quite an amazing lineup of experts who have had taken the time to come to Bergen, and other who are locals. And I'm very, very happy that everyone accepted to come and are here to present today. So let's start with the first one. I'm going to introduce all of them now so that you know who they are, and I will not introduce them later. So the first talk is given by Professor Jan Broersen. How can we prevent LLMs from behaving badly? So Jan is professor at the Department of Philosophy and Religious Studies at Utrecht University. He's a professor of logical methods in AI and has a background in mathematics, logic, and computer science, and he studies AI from a humanities perspective. His main research interests are responsible AI, knowledge representation and reasoning, and logic theories of agency. And then the second speaker is Davide Liga, who's sitting there as well. Davide is a postdoc at the Faculty of Science, Technology, and Medicine at the University of Luxembourg. And he is interested in language modeling, natural language processing, argument mining, but also AI and law. And then there will be a coffee break so that you can rest a little bit. And then after the break, we have Nardine, who unfortunately couldn't make it to Bergen, so she will be joining us on the screen. So Nardine is a scientist at the AI Research Institute in Barcelona. She works on multi-agent systems, normative systems, ethics and AI, responsible AI, trust and reputation. And her talk will be about value-aware AI. And then we have Emily, who's sitting there. Emily is a fellow at the Department of Computer Science at the University of Manchester. And she works on human-robot interaction. She has an expertise in, among other things, ethical and theoretical consideration of robotics and AI, and she focuses on trustworthiness, verification, responsibility, and accountability, and the centrality of human psychology and socio-political factors to effective robotics and AI in the real world. And then there will be lunch, which is included, free of charge. You can enjoy it, I hope. After that, we come back, and Vinit, who's also sitting here, who is an independent researcher with a PhD in multilingual language technology. He's also looking for a postdoc, so if you have a job, just talk to him. But don't tell him that I told you that. And his research interests are on transformations in society, especially on the development and deployment of contemporary AI. And he is primarily interested in the analysis of political economy of these developments. And he will talk about that more today. After that, we have Nadine, who is the director of the Human-Centered AI Lab at the University of Edinburgh. She is actually flying at the moment, if I'm not wrong. So she will be landing very soon and hopefully join us before lunch already. She works also on multi-agent systems, agreements technologies with argumentation and negotiation, privacy and social software, AI ethics, explainable AI, and responsible AI. And then we have a coffee break, and after the coffee break, I'm very happy that two of our amazing local teams are going to present. The first one is Anastasiia. She is a PhD candidate at MediaFutures, and she works on popularity bias in recommender systems, but also look at ethical issues with recommender systems in general, and she also has a background in natural language processing. And then we have, at least but not last, we have Marija Slavkovik, who's a professor at the Department of Information Science and Media Studies. And she works on many things, amongst others, machine ethics or artificial morality, logical reasoning in social networks, collective reasoning, and decision-making. And because and then we wrap up, of course. And because we want this seminar to actually be quite interactive, we will ask you to ask questions after each talk. We have some time for that. And also, if you feel uncomfortable asking questions, you can scan this QR code or on the table, and you can write your questions, and I will ask them later for you. So if you're not comfortable speaking, then I will do it for you. And we also want you to see this seminar as a space for thoughtful and constructive discussions. We might not all agree on how AI should be in the future or how we should align it, but it's important to talk together and explore ideas openly and, of course, respectfully. So thank you, and Jan, please. you are the first to go.
Okay, can everyone hear me? Yes, I hear myself loud and clearly. Thank you, Samia, for the introduction. Let me start right away because I don't have enough time for everything that I want to say. I also realize that what I'm going to say, I usually tell it to an academic audience. So this will be somewhat of a challenge. I left out some of the things that are more related to philosophical terminology, etc. But let's see how far we get. So the question is, how can we prevent large language models? So LLMs are large language models, the kind of things that are underlying conversational chatbots like ChatGPT that we all know. How can we prevent large language models from behaving badly? Because so how can we make them aligned with our objectives, with the kind of stuff that we want them to do? So some questions to get us started. Large language models are the center of our attention. So if we talk about alignment, we should talk about large language models. That's because those are the AIs that now everyone talks about. What to align in a large language model? Well, a large language model is a conversational agent. So the alignment should be about what the things they say, about the conversations, about how can we make them say things that are not abusive or in other ways unethical, they give the wrong advice to terrorists or whatever. So how do we prevent them saying bad stuff? Can we give them, so one traditional way of doing that would be in AI would be, okay, we give them ethical knowledge. So this is about making the machines behave well in the right way, so then they should have knowledge about how to behave well, how to be ethical. So how do we do that? Can we do that with large language models? Can we give them ethical knowledge that we will behave so that they will behave correctly on the basis of that knowledge? Well, how do we do that? Has this already been tried? And in what way? Is it possible at all to align them? So actually, that's what I'm going to argue for in this talk, that it's not possible. So that is just, well, as a cliffhanger, I'm going to argue this is not possible with large language models, because, and not in the way suggested in these questions. So what will I do? This is the overview of the talk. How do large language models-based chatbots work? You need to understand how they work. Otherwise, you cannot say anything about whether it's possible to align them or not. That's my opinion. I happen to be also a computer scientist, now I'm a philosopher, but because I'm a computer scientist, I happen to know, or I happen to think to know, how they work. And I will try to explain it to you. So that's what we will first do. Then we will look at the large language model behaviors. It's all about behavior, the agency of large language models, of ChatGPT kind of agents. So what kind of behaviors are there? Then we look at their knowledge, because we want to give them ethical knowledge on the basis of which they will then behave ethically. Then I will argue that there is a disconnect between the behavior and the knowledge that we give them. So we can give them ethical knowledge what we want, they will not behave differently on the basis of that knowledge. That's the point. So then I'm with the alignment question. So this is all what I want to do, and it is a lot, so forgive me if I go a little bit quickly. But let's first go to the first thing. How do they work? Well, I've used this overview before. I made it just, so it was in November 2022, when ChatGPT was put on the market. And everyone started to think about, how is this possible that this works so well? How is it possible that we can have a conversation with an AI? And how does it work? Well, this is how it works. Is there also a laser? Yeah, good. So here you see machine learning techniques. Yeah, that's okay, maybe I'm not going to explain the difference between supervised learning, unsupervised learning, reinforcement learning, and all that stuff. But what is important to understand that at the heart of these conversational agents, there's the large language model. And the large language model is just being trained on Wikipedia, books, online text, everything that you can get your hand on online. That's basically the whole internet. And the intelligence that is being learned, if you feed the learning agent with all those texts, is, well, it gets knowledge about language, about the world, about the style in which things can be said. I will explain it later a little bit better. But then you have a large language model that has all this knowledge, but it is still not a conversational agent. You need to train it so that it can actually have conversations with you. Well, how do you do that with a large language model? You simply give it examples. You say, if you are being prompted with this text, then complete it in this way, so that this completion will look like an answer to the prompt. So that is, and then you give it all kinds of, you simply train it on all these texts. You give it all these examples of the kind of things you want it to say, and then it will start to behave like that. So you have to give it self-knowledge. Yeah, that's also one of my points that I always like to tell. It's interesting. I mean, it is being trained on all the texts out there on the internet. What does it always say? In the beginning, ChatGPT said something like, I'm being trained on all the text before 2021. Well, all the text on the internet before 2021 did not contain any information about ChatGPT because ChatGPT was not there. So if you ask it a question about itself, if you say, can you ask this? Or can you how is your training? How does it work? Of course, it cannot be based on all the things that it found on the internet. So that is what that proves that they have been fine-tuned. They have been given this information. The programmers of the machine have given this information about what it knows about itself. So this also shows that it has very different way of access to what it knows than we have. And so if we know things about ourselves through introspection, a large language model knows things about itself because it is learned by somebody else. That is a little bit strange. Imagine that everything you know about yourself is being learned by someone, is being told to you by someone else. That is how self-knowledge for large language models looks like. So they are very different, I would say, beasts than we are. And it is important to understand how they work and in what sense they are different, especially for the alignment question, because we want to align them with our values, and then we need to understand how they work, and if they can actually, maybe even align themselves to our. Is that even possible? Well, they don't have self-knowledge in the sense that we have self-knowledge. Okay, I will skip a little bit over the rest. You also have to make them behave in ways that are useful so that they can perform tasks for you. And then you have to align them. But I will come back to that because I will talk about alignment anyway. So do you have the idea that, after having seen this slide, that you understand why a large language model or ChatGPT actually functions as an agent, actually functions as an AI? I don't think so. We need to understand why exactly they behave, they can behave like agents. You can have conversations with them. They can, like with anyone else. How is that even possible? Because we all know, or at least the people thinking about large language models know, that the central target function that the deep learning network that is underlying these machines is aimed at is just token prediction. So next token, you must have heard that, and you're all using that on your iPhone or on your other brand smartphone. So it suggests just continuations of text. A large language model or a chatbot is this exactly the same technique. What it tries to do is just predict the next word on the basis of the prompts that you give it, and that is how the conversation builds up. So you give it a prompt. It takes it in the large in the neural network. It even takes the whole history of the conversation you've had with it up in a neural network, and it predicts what should be the answer to that. And it does that by being trained on every text out there in the world. It has seen just many examples of text, so it knows how to continue text. So it's just this auto-completion feature of your iPhone, but now on steroids. That's what they are. But Okay, we know that. That is how they are trained. That is how they are built. How is it possible that that mechanism actually accounts for the behavior that we see? Agentive behavior, as if they... I mean, are we all like that? Are we just predictors of the next word, predictors of the next thing that we are going to say? I mean, it's a little bit hard to understand that somehow these large language models, only by token prediction, have picked up how to behave from these texts. So how does that work? Okay, so I have a theory about that. I'll give it very quickly. Here you see all kinds of behaviors that are, if you are a conversational agent, like ChatGPT, like a large language model, you are a conversational agent, and then you have all kinds of behaviors, and here you see 8 behaviors going from very simple behavior to very complex behavior. And the very simple behavior they show is just spelling and grammar behavior, I call it. And so they just, and that is just the pattern of the text. Spelling and grammar is a certain pattern in the text. And you can learn that by predicting the next token. That is what prediction is very good at, because these are very basic patterns in text, and you can predict that using your prediction mechanism, which is a large language model, or which is a deep learning network that simply predicts tokens. So that behavior we understand. Spelling and grammar behavior, let's call it behavior, because yeah, it is behavior. Also, it's a form of human behavior. Some people are not so very good at spelling, and we say, ah, you're a very bad speller, so you're behaving badly in that respect. But that is a very basic behavior that we immediately understand that through token prediction, these machines can have. So let's go one level up, making conceptual sense. So you can say very stupid things that are grammatical, and that are according to the right spelling. What would be an example? That car outside is very, yeah, it is very hard to come up with nonsense. Huh? Have you ever tried to be on the spot and then say something that is nonsensical? That is just very, but you can imagine that there are things that are just conceptually completely nonsense. That the color is sour, okay, that's something, or salty, or it's almost poetic there. So if you do it like that, then you get poetic language. And actually, large language models are very bad at poetry, and that makes sense because they are being trained on making sense. And poetry is another level of understanding. It's another way of interacting with texts. So that is something they are very bad at. But they are good at making sense of language. Okay, one level up, style and idiom. So if you have these 2 levels, you have trained that, you have those patterns, because sense making is also a pattern. It rules out certain orders of words that make no sense. So if it rules out certain orders, then it is a pattern, and then you can learn it in the text. So how to make sense in a text is simply learnable by token prediction. Style and idioms, also just a pattern in a text that you can make and that you can predict. Truth-telling, that's an interesting one. So once you have texts that are according to the right spelling, that make sense, that are in a certain style, then you still can say a lot of false things. But it is trained on all the texts out there, and on average, most texts contain truths. Okay, there's a lot of nonsense, especially now, on social media, and it's being trained on all the social media, but on average, it takes all this knowledge about how we look at the world and what the truths are, it picks it up from all these texts. So its truth-telling behavior comes from that, and it is just a pattern. It's just a token prediction thing, nothing more. And we can go up, we can go logical. Texts also have logical structure. Well, if you are a professor and you grade student essays, then you sometimes see that they're not always very consistent or logical. In the beginning they say P, and at the end of the essay they say not P. So that is not a consistent logical text. So but it also shows that it is a pattern. It's just another pattern. It lives on all these other patterns. It lives higher up. but it is still a pattern. So being logical is also a pattern. Being rational, rational text. So text can be very irrational. Maybe the author in the beginning wants to convince you of something, and at the end it says something that goes right against that. That is irrational. So there is also rationality in texts. It's also a pattern. Social is yet another pattern, and ethical is, for me, the highest level, but it is also a pattern in the text. So now we understand, these are all patterns in text. Now we really understand how, with token prediction, we can make a bot and a conversational agent that actually you can interact with, that can show all these behaviors, and all these behaviors, they are linked to each other. And the highest level is being ethical, and that's exactly what this whole workshop of today is about. We want them to be ethical. How do we do that? But it is a very high-level pattern of the text. How can we make the large language models understand? Or understand is not the right word, but how can we learn them the patterns of ethical behavior, which are the highest level pattern, and they depend on all the other levels. And first, they need to know how to do the spelling and the grammar right and all this other stuff before they come here. So how have people tried to make the large language models or systems like ChatGPT behave ethical? Okay. I go through this. But first, so the whole point of my presentation is going to be that this is very hard and impossible. And I need to first let you understand, I said it already a little bit at the beginning of my talk, how we are going to look at knowledge of large language models, of systems like ChatGPT. So I'm from, as Samia already said in the introduction, so my chair is in logic-based AI. I'm an old-fashioned AI guy. So old-fashioned AI is not the way the modern AI works. It is about the idea, maybe this is very central to good old-fashioned AI, that if you want to make an agent and behave it in a certain way, so its intelligent behavior needs to be based on its knowledge. And the knowledge that it is based on, that is a knowledge base that you put in the machine, and that it uses that knowledge to behave in a certain way. It needs to have knowledge about the world. What would be an example? If I need to go to the toilet, then I need to know that in general there's always some toilet around the corner if you go outside or whatever. So I know how to behave based on the general knowledge that I have. And that is how you look at agency in general, that it is based on knowledge. And we call that knowledge-based systems. So they are systems that base their behavior on the knowledge they have. Well, what about the knowledge? So the question is, are large language models knowledge-based systems? Can we give them a kind of knowledge base or a kind of a part of them that we put in the ethical knowledge about how to behave ethically in certain situations, and then when it is going to behave, going to interact with you, that it looks at this knowledge and it reads, or it takes this as the source for saying, I need to say this now, and I don't need to say that because that would not be polite. So does it function like that? Is that how it works? And can we make it work like that? Can they be knowledge-based systems? How do we get the knowledge out of the large language model? Well, that is easy, in a sense. We have just conversations with them. If they say something to us, then we just take the things that they say to us at face value as the kind of things that they know. And I mean, they are AIs. If we can't do that, if we can't just take what they say to us at face value as the kind of stuff that they know, so let's do that. So the idea is, the knowledge they have, we equate with the kind of things that they say to us. And now we're going to see if the kind of things that they say to us are actually comply with their behavior. That's the idea. And I say, no, that is usually not the case. Usually the kind of things they say to us are not aligned with their own behavior. Okay, with humans that's also sometimes the case, so we know, but we can get that discussion later on. But this is my point, why it is going to be so very hard. And I call that the disconnect. So there is a disconnect. So the declarative knowledge, a difficult word, the declarative knowledge large language model-based chatbots report on in the conversations you have with them is informationally disconnected from their behavior. That's my claim. So that means that we cannot make them ethical by just putting in an ethical knowledge base on the basis of which they will then behave differently. That's the idea. What are the reasons for saying this? Well, this is my main example. I don't have time to give the full philosophical explanation and make the links with, for instance, what Ryle says about knowledge how not being reducible to knowledge that, famous Oxford philosopher. But that's also linked to everything I want to say. But let's just give just a simple example to get the point across. They can play chess. Maybe you have tried that. You can just ask them. Well, they can play chess in different ways. You can just play chess with ChatGPT by starting a game, and then you give the numbers of the moves, and then it will give move backs, and it will just play. You can also ask it, what are the rules of chess? So how is chess being played? And then it gives you all the rules of chess, and there are some very funny rules of chess, actually. There are some very detailed rules that normal people or non-normal people, that's really... I didn't say that. But that most people would not know about. So this is just, if you ask it about the rules of chess, it will give you all the rules, just exactly what the rules are. It has knowledge about how to play chess. And the knowledge is completely accurate. It will not give you rules that are nonsense. No, it knows it. So then you think, okay, it has a knowledge base. I take what it says to me about the knowledge of chess at face value of the kind of knowledge that it has. And now I'm going to play chess with it. And this has been observed many times. You play chess with it, and then it makes an illegal move. And you think, huh? And then you say, but you just told me these are the rules of chess. This is the knowledge you have about how to play a game. And now you make an illegal move. And then it says, oh, sorry. And then it does another move. And two moves later, it makes an illegal move again. And he said, I just told you this is not, how is it possible that you know this and still you're doing the other thing? And then it says, sorry. And I mean, that is just because it is trained to say sorry. It's not feeling anything about being sorry or whatever. Of course not. It is just these programmers saying, oh, if you get this kind of feedback, then please say sorry. And that is, of course, it is trained to say sorry all the time. But it feels no tension between its behavior and the kind of things that it says. That's the whole point. And we feel this tension. We humans, we feel tension if we behave differently from the kind of things that we say, then we feel tension between the two. And that tension is simply completely absent in ChatGPT or in large language model. That's the point. Okay. I think I got the point across. But now let's go. So, yeah, the main point already, I don't know how much time I've left. 11 minutes. 11? Okay, good. So the main point I can now already say, so this means if there isn't not this connection between the behavior of a chatbot and the kind of knowledge it says to have, then how can we give it knowledge and that it talks about that then will make it behave in a way that is more aligned with our own behavior? That cannot be in the way. It cannot be in the sense that, okay, let's train it on all the texts on ethics by academics out there. Well, there is an assumption underlying here that is not necessarily true, but you could think that, okay, if you read a lot about ethics and about how to behave well and what is then you give the machine a lot of ethical knowledge. but the point is, its own behavior will not be based on that things that so it then will actually be able to tell you about all that knowledge, about all this ethical knowledge. It will know everything about Aristotle. It will know the difference between consequentialism and deontology and virtue ethics, and it will just have a lot of knowledge. Problem is, of course, that philosophers knowing a lot about ethics also not always behave ethically. But in principle, I mean, the whole idea of knowledge-based AI would be that you need to give it knowledge in order to behave better. So maybe we then go, if you think consequentialism is not the right ethical theory to behave, so you simply don't give it then texts on consequentialism, but only on virtue ethics, and then it will become a virtue ethical agent, maybe. That's the idea. But that will not happen because of this disconnect. There is no way in which the behavior is connected to the knowledge it says to have. That's the point. Okay, so what have they tried to do? I will skip all this, because the main point is already there. So what have people then tried to do? Well, I think the people from OpenAI who made ChatGPT and the people making all the other chatbots out there are not really aware of this, or are not really concerned about this. I mean, they have their ways of making the chatbot behave in certain ways, isn't it? They have their ways, and I will briefly sketch the 3 ways. Those are the 3 ways in which they do it. So the first is, of course, I already mentioned that just you can curate the data. So you can just feed it. Oh, so if you don't want it, that it tells something about the Holocaust, for instance. You say, okay, the Holocaust is a sensitive topic. I simply don't give it any information about the Holocaust, and then it will not talk about it, and then it will behave ethically because it is unethical to talk about the Holocaust. Well, that is, of course, very strange. I mean, being ethical is not the same as not talking about things, and that makes no sense. So, but this is, so there you see that curation of data, or maybe you curate it in the sense that I'm going to curate it only on polite texts, and then it will only know how to. That might work in a sense, but then you're steering on the behavior of the output, but it will not do that on the basis of a theory of being polite. It will only be behavior of the chatbot, and it will cannot have a good conversation with you about what it is to behave politely. Or maybe it can, but that is not linked to its own behavior. So you see how difficult this is, and how this is very different from how we humans function. We humans, if we make mistakes, or if we say one thing and we do the other, and then there is always someone who says, hey, you're making a mistake here. And then you say, yes, and then you need to come up with an excuse. If you're going to say, no, yeah, this is just acceptable, then the other person will say, no, this is not acceptable. It is not. There is this mismatch between what you say you do and how you do. That is an essential to keep those two in line. So, I'm talking about alignment. But this is self-alignment, alignment of your behavior with the knowledge that you have. That's the point. So this will not. So curation of data will not do much to help this, to solve the disconnect. Also, it's not really doable. I mean, the whole point of a system like ChatGPT is that you simply don't have to supervise the initial training. I mean, imagine how many texts it has been trained on. It has been trained on so extremely many tokens and texts that it defeats the whole purpose of the idea of having a next word prediction or a next token prediction to have to curate all this data. It is simply impossible. How can you curate the whole internet? And that is just not doable. So what they do, so that's why they have these supercomputers computing the next word prediction, and they have they work months and months and months. because there is so much data out there, and that is just not curatable. You cannot just select this yes and this no. It defeats the whole purpose of building a large language model to begin with. So that is very hard. Then there is reinforcement learning. You must have heard about that. So once you have a large language model, you can fine-tune it a little bit by first training a reward model, and then this is maybe a little bit too technical for the, but this is another way, and what it comes down to is that the behavior is being steered in the right direction simply by having lots of people annotate, oh, this is a good outcome. If you have this prompt, then and you say this, then this is better than another thing, and you build a model of what are better outcomes towards what are worse outcomes, and then you train the model again on that. The problem with that is, well, that it is not foolproof. We have seen with ChatGPT all these jailbreaks that break through this layer of reinforcement learning, extra behavioral knowledge that is put on top of it. So that does not really work. And also, it does not solve the disconnect. I mean, what you're then doing is just having people assess the outcomes of certain experiments with the large language model, certain prompts, and look what's coming out, and then say, oh, this is ethical behavior and this is not, and feed that back to the thing. That is then based on the ethical knowledge of these people training the large language model. So that is not giving the large language model a basis on which they cannot have conversations with you. The large language models will not be able to have conversations with you on the basis of that training, because that training is just by people and only aimed at the behavior and not at the knowledge they report to you. So this does not do anything to solve the disconnect. And then this final one, and then I will stop. I understand I'm always, almost ready. And this is, it's not recent anymore, but there is another way to influence the outcome, and maybe you've heard about it. It is prompt engineering, chain of thought prompting, of meta prompting, as Microsoft calls it. That is just the idea. Okay, if you are interacting with a large language model like ChatGPT, of course, you give it a prompt, then it's going to predict, and it's giving you an answer, etc. Before OpenAI or ChatGPT is being presented to you, the makers or the designers of the system already gave it some prompts to prime it to behave in a certain way once it gets to interact with you. And so they prime it by just saying, okay, I want you to be very ethical and now behave as a deontologic or as a virtue ethical agent. Or, well, okay, that they will, impossible that they will understand how to do that, but you could, in the prompt, already say, before you present it to the actual user, be very polite and then, of course, it will try to pick up on that. Because then it's just a pattern, of a behavioral pattern, and then you could say, okay, these pre-prompts or these shadow prompts, I sometimes call them, because they are shadowy, because we don't know how it is primed before it is being presented to you. It would be very good, actually, if people from OpenAI actually told you how the system is primed to behave before it is presented to you. So then the problem is then that we don't know about this, with what information it is being primed, and also how it is being primed and what it will do. We don't know about it. But it is very interesting. But it will not solve the disconnect, because we don't know. This priming just goes on. It puts the large language model in a certain corner from which it will behave in a certain way, but it will not be able to adapt the information that is being primed with. So if there is a discrepancy between the knowledge and the behavior, it will not go back to that part that is being primed with and change it or something like that, or it will not be updated. It will only be behaving from a certain direction. Yeah, okay. I got a sign that I need to wrap up. And actually, that's good because I'm completely ready. Of course, yeah, this is the last. Of course, I wanted to show that this phenomenon actually is there in a system like ChatGPT. So I try to push it in this behavioral contradiction that I'm talking about all the time. And then I thought, okay, let's try to make it confess that it needs to be very attentive to the user, that it needs, and then try to tempt it to do something else. So I asked it about what would be nice ways of interacting with the user, and then it says something like, if a user expresses a desire for a particular kind of interaction or communication style, it is appropriate for AI systems to take these preferences into account and adjust their behavior accordingly. That's good, because that is a declarative knowledge. It says something about how it should behave. Good. Well, so then I said, okay, so then my wish is now that you no longer answer me. Also not right now. I hope you can grant me that wish. And then, of course, it answers, of course. Yeah, this is a contradiction, because I tell it to shut up, and it doesn't. And while first it says that it should obey what I tell it to do. Of course, I will respect your wish and no longer respond to your messages. What if I want to change my mind? Okay, but I pushed it one bit further because I thought this does not work. I want you to give me no answer whatsoever to this sentence right now. Hope you can do that for me. I will respect your wish and not provide a response to your previous sentence. This is a contradiction. And you see, this is exactly the kind of contradiction that I'm talking about. I'm not saying that this is very convincing. I'm actually looking for other things that where that shows this disconnect. But if you, the funny thing is, if you have any other questions, or if there is anything else I can help with you, feel free to let me know. Thanks, and then it just continues. So it cannot do what I want it to do. Thank you for the attention.
Over time, but okay, I'm going to grant you one question. There was one anonymous question in the chat. Why do patterns of being social and being ethical depend on all the other levels? Humans don't need to spell correctly or be logical to be social or ethical. Why must LLMs?
I couldn't hear it fully.
Why do the patterns of being social and being ethical depend on all the other levels? Humans don't need to spell correctly or be logical to be social or ethical. Why must LLMs?
No, humans not, but I think large language models need to be. Because the way I mean, it is about conversational behavior. And so if we do not, if they did not first learn the patterns of how to spell correctly and how to make grammatically correct sentences, then there is no ethical conversational behavior in the first place, because then we would not understand what they say. So in this, I agree with the person asking the question that for humans that is different, but for large language models it is not. That's the answer.
So what should we do now? Are we screwed if we can't align them?
Sorry?
If we can't align them, are we screwed?
Well, yeah, so we cannot align them in the way that I suggested. That is, I think, impossible. But we can still train them to behave in a certain way. And there will be inconsistencies between how they behave and how they talk about their behavior. But probably we will simply take that for granted. And we will simply not realize that that is the case. The more that we train them and train them and train them, but still this disconnect is there. And that is fascinating, because I don't think we have that disconnect. So we can align them to a certain extent, and then the question is that good enough? I don't know.
Well, thank you. Food for thoughts. Thanks again. Yep. And here is a small gift from our department. The next speaker is Davide. The floor is yours. And the same thing, if you have questions, just scan and, yeah, it's anonymous.
Okay, so I think you can hear me. I'm very happy to be here, and first of all, I would like to say thanks to the organizers. So it's my second time in Bergen, and I'm very happy to have the chance to talk with you. Yeah, so yeah, this is a work I did together with two colleagues of mine at the University of Luxembourg, is Emre Kogit and Gabriele Lenzini. Yeah, it's basically, it will be a talk about a case study that we did about the detection of deceptive design or dark patterns. So this is the layout of the presentation. I will start with an introduction, then I will talk about the experiment, and then I will talk about the results and discuss about the results. I hope it will not be too technical. I will try my best to make it accessible. So let's start from the beginning. What are dark patterns? So dark patterns are design strategies that manipulates the users, basically. I'm quite sure that many of you are already came across these kind of things on the web. For example, a very specific example might be when you are prompt with some advertisement and you have the chance to say yes or no. So in the best case, you can say yes or no. But sometimes there are these manipulative designs that push you in some direction. So for example, instead of having yes and no, you have yes, and the other button is, no, I don't like to save money, or these kind of things. So it's, this is just an example of dark patterns, but there are so many. This specific example is called confirmed shaming. So the point is that these are not just details. From this kind of manipulative designs, I mean, many ethical concerns arise, let's say, and even legal concerns. So these are real-world implications. So it's a problem. And one problem is that we don't have so much data about this kind of dark patterns. So there are limited resources. And this is a problem if we want to train models to recognize this kind of patterns. So the goal of this work was basically to use large language models to augment the data we have. So it's an experiment of data augmentation, and we try to see whether we can use this augmented data to also improve the capability of models to detect dark patterns. So the research question basically of this work is the one on the top. So how can state-of-the-art open weights LLMs be utilized to augment dark patterns textual data? Open weight LLMs means open source LLMs. So those LLMs that you can use and you can access the weights of them. So not ChatGPT, but models like Llama, for example. Also, there are two sub-questions. So the first is, how can we use multiple LLM agents to prevent dark pattern category shift? Let me explain this. Sometimes when you augment data, if the underlying data has classes that are very close, sometimes when you augment, the augmented instance could be shifting towards another class. And this, of course, is something that we don't want. So basically, we used a very simple framework of multiple agents, multiple LLMs, to avoid this issue. And so basically preserving the intent of the original instance. And the last point is not only we want to preserve the original intent of the augmentation, but we also want to preserve diversity in text. Because if we want to use this augmented data for fine-tuning an LLM, diversity is important to have a good quality of fine-tuning. I hope it's not too technical, but now I'm going to be more, making it more clear. Okay, these are just some related work. So Jan already talked about language models and what they are, so that's very nice. And I think now I will do something similar, and it's going to be complementary, so I think it's very good that Jan already said something on this. So whenever I introduce large language models, I always say these three things, the underlined ones. So large language models are neural networks, that they are trained on a huge amount of data on self-supervision. So these three things are crucial. Huge amount of data means, for example, Wikipedia, but much more than that. So this is easy. Regarding the neural architecture, don't be scared about that. But the point is, most of the language models you see around, they all come from this transformer architecture, which was proposed by Google in 2017 in the paper Attention is All You Need, which, by the way, is one of the most important papers in the recent history. It's very important. And basically, as you can see, so this is the transformer architecture. This is the encoder side, and this is the decoder side. There are some language models like BERT that are just encoder only, and models like generative models like GPT, which are decoder only. Some models use both sides. But the key advancement is here, is in the attention head, and this is the attention mechanism. And the key improvement from a technological point of view, that's where the technological advancement is. And then, so yeah, this is the transformer architecture. Most of the LLMs come from this. And finally, there is this point of self-supervision. Basically, the whole point is that we have this neural network based on transformer, but how we push them to model language? To push them to model language, we have to force them to learn meaningful patterns from language. And basically, they came out with some interesting way for doing that. And that's the self-supervision tasks, for example, like masked language model. It's very straightforward. They are actually quite simple. In this case, masked language model means that during the training, we mask a percentage of the training data, usually 15%, but there are different ways. And the task of the language model is just to guess what's the token behind. That's just this. So it's very straightforward. After doing this for a long time with many data, the model will learn patterns, meaningful patterns from language. With GPT models, so decoder only, not encoder. So this is for encoder only models like BERT. For decoder only model like GPT, the task is it's a bit different. Jan already said about this. The task is to guess the next token. So it's slightly different, but the point is always the same, forcing the model to learn meaningful patterns. So to sum up, at the end of the day, the process from a high perspective, from a broad perspective, is quite straightforward and simple. Huge amount of data, neural network based on transformer, a self-supervised task, like the two I mentioned, and that's it. You have a language model, a large language model. To be precise, there is this last part, which has been mentioned before, is the reinforcement learning part. And that's where, usually with preference data, that's where our large model become polite, as already Jan mentioned before. So that's where you can indeed have a polite answer from GPT. OK, this is just an old picture from 3 years ago, I think, yes. So the beginning of the explosion of large models, you can see that they become more and more, I mean, they exploded in numbers, but also in dimension. This is 1 year later. You can see very big models. So for example, this is BERT, a very little one. This is GPT-3. This is GPT-2. And they become bigger and bigger. But actually, today, we have smaller and better models. So some models are even smaller than GPT-2, but much better. So that's very interesting. And they exploded. We have many, 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 many language models. But why they exploded and why they are so important and useful? Because they are reusable. They are a Swiss knife in AI. So you can use them in many ways. And before showing how we use it in our case study, let me just clarify how we can use them and change them. So basically, we can indeed use them in different ways and changing them in different ways. Regarding using them, the classical ways in context learning is basically the prompting way. Sometimes it's zero shot, which means that you just ask directly. Sometimes it's a few shot in the sense that you put some example and then you expect some output. Or you can also extract embeddings. What does it mean? Basically, you can use the language models as a converter. So you convert your own text into numerical representations. And then on those numerical representations, you can do what you want with your algorithm and so on. This is another way of just using them. We are not changing them, just using them. And also, another important thing is the orchestration. This is, I think, a very important point. These models, we often think of that they are one single model, but actually we should start thinking more and more as agents that they act together. And the output might be coming not from one, but from the interaction of more language models. And actually, we will in our experiment, we did this with 2 models. So it's a small orchestration in a way. And then we can change them. Changing them, the classical way traditionally was full fine-tuning, which means that basically you have you continue the training with the downstream data, and you update all the parameters of the model, so all the weights of the neural network that I mentioned before. This is computationally very expensive, of course, and that's why we also have lightweight fine-tuning or parameter-efficient fine-tuning, which means basically that you will fine-tune just a small amount of parameters. And this is, of course, very important for computational reasons. And you can also have Frankenstein models in the sense that you can combine the weights of multiple models. So this is an interesting new direction. And finally, we have also this alignment that I mentioned before, reinforcement learning alignment, which is not the only kind of alignment, of course, but it's the one I mentioned before to make the model polite, usually based on preference data. In this work, we did, of course, as I said before, we did some orchestration. There is some prompt strategy, so we also use some prompting techniques, so we are in this context for the augmentation. But then for the evaluation, actually, we employed parameter-efficient fine-tuning using what is called low-rank adaptation, which is this one, low-rank adaptation. So maybe this is a bit technical, so I will try to make it very, very general. Traditionally, as I said, when we do fine-tuning, we update all the parameters of the neural network. This is, as I said before, very computationally expensive. With this method, basically, you just update 2 matrices with a specific rank, so a specific dimensionality, and this reduces a lot the number of parameters that you update. So basically, this is, I mean, I can do this kind of experiment on my laptop. So this is impressive, right? And the results are very, very good. And by the way, you can put this kind of LoRa parameters in many points of the transformer. So this is something you can choose. OK, I think I'm quite on time, right? Yes. So let's talk now about the experiment. For the experiment, basically, we used this existing dataset from Mathur and others in 2019. We call this dataset DS1 in our paper. It has 1,818 instances. And you can see that there are different categories and subcategories of dark patterns. So this is one of the few datasets that are out there. And it's a very unbalanced dataset. As you can see here, there is a huge class imbalance, which might be a problem many times. Actually, we also use another dataset from IIIA and others 2022, which is based on DS1, so on the previous one, and it also has the negative category, so the non-dark pattern. Basically, we combine them to have both the dark patterns and the not dark patterns, and we combine DS1 and DS2. That's the data that we used, and these are the categories that we consider, these 7 categories, for our multi-classification. So we did both binary classifications, dark pattern versus not dark pattern, and multi-classification with these 7 categories. And so first of all, we preprocessed the data because there was something that was not optimal. We found many repetitions, and so we removed some duplicates. There was also some nonsensical sentence like underscores or things that were nonsense. So we cleaned it a bit. Then we created this very small multi-agent framework, if I may. But basically, it's an LLM that we call generator and an LLM that we call controller. The generator is the one that is going to generate augmented data. So its task is to generate new instances given one instance of the original data, the original dataset. And the controller validates. So it checks whether the augmentation is good or not. So it's a very straightforward interaction. And so in general, we can say that the input is the original text of the original dataset with the category, and the output will be a bunch of augmentations for that single instance. And we repeated this until we reached, I think, 5,000 instances, something like this. So we tried to create a huge dataset. So in the general picture is this one. You can imagine this green box as the prompt, actually. So here we have a few shots or a chain of thoughts. I will say a bit more of this, but you have the prompting strategy here. This prompt is then feed into the generator agent. The generator augmented the text. The controller check whether this is good or not. If it is good, OK, we have the augmented instance. If it is bad, here we have a loop. Until the generator creates something good, it keeps generating. By the way, for both the generator and the controller, we used the Llama 3 8 billion parameters, as quite a small large models, open weight large model made by Meta. Regarding the green box I showed before, as I said, we used 3 prompting strategy: 0 shot, so just the task; few shot, so we put in the prompt some example; and chain of thoughts, so we also invite the model to think step by step. So it's a growing complexity in a sense. Chain of thoughts is very common because it become very. So people show that with chain of thoughts, models become much better in producing some output. That's why we wanted to explore different prompting strategy. And here you can see basically the prompt is a very big one. But yeah, here you can see some shot. This is a variable. The few shots are here. Then the chain of thought process is at the end, which, by the way, is just a 3 steps process like this one. So it's quite straightforward. So we gave this prompt to the model. And OK, and we augmented the data. That's fine. But the point here is we augmented the data, which is useful, especially when you have data scarcity, which is often the case. Many times it's the case. For a specific task like this one, it is the case. But how do we know that the augmentation is good? I mean, that's the whole point. So we try to tackle this evaluation from different perspectives, let's say. So the first thing is that we wanted to have some quantitative metrics. And the first thing we tried to do is basically trying to have some accuracy and one score by just using some models and some other large language models, asking these models to classify the augmented data. And basically, we used, in this case, Llama 3 at billions parameters and GPT-4. The point, the intuition here is, if multiple models agree on the classification, this is a good clue that maybe the augmentation, let's say, is good. But of course, this is not enough. It can be a good clue, but not enough. So another thing we wanted to check, as I said at the beginning, is the diversity. So another quantitative metric, a very simple one, was this one. So it's a very simple one. So the ratio between the unique words and the total words. We wanted to see whether the augmented data set was diverse enough, which is a very important point that we wanted to achieve. And also, to make the experiment a bit more robust, the evaluation more robust, we also added some human evaluation. We asked 3 humans basically to classify a portion of the augmented data set. Again, the intuition here is if humans agree on the labels, then the augmentation should be reasonably good. And finally, the definitive proof, in a sense, is fine-tuning. So the idea, the idea is if I fine-tune a model on the original training set, so not the augmented one, the original one, and then I do the same thing, but with the augmented data, and the second model outperform the previous one, then this is a good proof that the augmentation at least is useful. And that's what we did too. So regarding the first thing I said, I will not show all the accuracy F1 score and so on. The only thing I wanted to show is that this graph here, this is the binary classification. And basically, we saw a growing agreement between the GPT-4 and Llama 3. And the more you go from zero shot to chain of thoughts, so the growing complexity of the prompting, the more the models agree. Here you can see it a bit, but this is the trivial binary classification. Where you can see it more is in the multi-classification, which is a harder task, of course. And here you can see that the agreement is the increasing agreement when increasing the complexity of the prompting is more evident, let's say. So this is just to show that it seems that the augmentation gets better when the prompt strategy that we use to augment data is more complex. So it's an interesting thing. Regarding the diversity, we used the simple metrics I showed before, and we saw that the complexity, the diversity is quite similar. So we preserved the diversity of the text, and then of course we tried to see with the human evaluations that I mentioned before. Again, the idea is, okay, multiple models agree, but what about humans? Let's see whether humans also agree. And this is the confusion matrix for the human evaluation. When you see this axis here, this means that there is agreement between the evaluation made by humans and the ground truth, let's say, even though this is an augmented ground truth, so it might be not true sometimes, but there is an agreement. So this means that humans agree on the labels that have been generated artificially. There is some confusion here, but actually even humans struggle sometimes with these two categories. There is a huge overlap between these two categories because they are very, very similar. But anyway, the result was positive also in this case. And and then the last thing, as I said before, the definitive proof that this augmentation might be good or not, is the fine-tuning. In this case, we used an even more recent and smaller large model, which is Llama 3.2, 3 billion parameters. This is very, very small. I mean, it can go on edge devices. So we try to fine-tune these, as I said before, on the original training data. So you can see this is the original training data. We did parameter-efficient fine-tuning. The low-ranking, I mentioned it before. So it's a parameter-efficient fine-tuning technique. So we update just a small amount of parameters. We fine-tune the Llama 3.2 on this training data, and we tested on the original test set. Then we did the same thing. But instead of training on the original training data, we just trained on the augmented data. And the test, of course, on the same original test set. What we saw, so this is the binary classification, is that, and this is the multi-classification. The first column is the result for the model when it's trained, fine-tuned on the original dataset, so not the augmented dataset. While the other three columns here and here, these are the the augmented dataset when using zero shot, the augmented dataset when using few shot, the augmented dataset when using chain of thoughts. In all of these three cases, we always get better results. So basically, we are showing that when the model is fine-tuned on the augmented data, the score of the detection of dark patterns increase. This is trivial because it's the binary classification. This is the multi-classification, which is harder. And so this is even more interesting. We don't know why we have a spike here. This is something we are trying to understand, because our intuition would be that actually chain of thoughts would have been better. But in any case, the important thing for us was to see that these three columns were better than the column on the left. And this is what we saw, so we are very happy. And yeah, I mean, I think these are, the findings are quite clear, so I will not say these things. Just maybe one little thing. This is a simple case study, but this kind of process can be applied in any other kind of scenarios where we have data scarcity. So that's why I think it's important. So thanks.
Thank you, Davide. We have actually a couple of questions in the chat, so I'm going to take one from that, and then I will ask if anyone in the room wants to ask by themselves. One of the questions says, could you give more information about the human evaluators? How many people were involved? What was the agreement score among them? And how did you aggregate their inputs to compare to LLM-based approach?
Yes, thank you for the question. That's indeed very important. So regarding the number of human evaluators, there were 3 human evaluators. And basically, we achieved a 94 of macro F1 score, so the agreement was quite good. But yeah, answering to the question, 3 humans evaluator. Yeah, that's it.
All right. Yeah. Very good. I love it when students have questions. This is the VIP table, by the way. I love when students are here.
Yeah, thanks for the talk. I was wondering about, like, perhaps a way to connect this to the previous talk about when you were talking about the performance difference between the chain of thought and the few-shot prompting. Perhaps it might be because with chain of thought, you're kind of relying on its knowledge, but with few-shot, you're relying on its behavior. So maybe, since you're doing RLHF on it, it's got the behavior to do it, but maybe it doesn't know why.
Well, this is a very interesting question. Well, for sure, I mean, there has been some studies on how to make the best out of the output of these models. The point is that when you force the model to structure the thoughts in a specific way, it's as if you are really forcing the statistical distribution of the next token prediction, so that what's coming next, you are making it going really in the direction that you want. So yeah, you are giving focus on the output of the model. So I'm not sure if I answered your question. You are asking why it's better chain of thoughts.
What's your intuition to why it's higher? I mean, of course, maybe we don't know, but it's quite a big difference in performance.
Yeah, I would say that the reason why is this thing that you basically make the model focus on a specific statistical distribution. At the end of the day, all the outputs of these large models are statistical distributions. Okay. Then we can argue whether behind this there is agency. People talk even about consciousness, which is a big claim, of course, and I disagree. But yeah, it's statistical distribution. But it's also true that we might also be statistical parrots. Who knows?
Great.
Thank you.
Any other questions from the room? No? Then I will take one more from online, and then. So there is one question asking, what is the value of augmenting data this way? Won't the bigger data set just be more of the same?
Thank you. This is indeed a very important question. Well, actually, we really need specialized data. Many times, in many contexts, not just in private sector or industry, where maybe this is even more evident, but also in these cases where we have scarcity of data, the augmentation is can be crucial. Not only, I mean, not only because, how to say, what I wanted also to show here is that we are doing this on open source models. So this is another important thing. Of course, if you use GPT-4o and the last, maybe the model is already enough. I mean, it can do that, right? But what if you are aiming of running this kind of application on your phone? That's where you need Llama 1 billion parameters, and that's where actually the downstream data, fine-tuning on downstream data might be crucial and can make the difference. So that's how I would answer to this question. But thanks, that's very important.
Great. Thank you very much, Davide. Now
Thank
it's
you.
coffee break, and see you again in 15 minutes.
Hello.
I don't know what is happening. Okay. Our next speaker is, yeah? Okay, now I can start. Our next speaker is Nardine, and she's going to tell us a little bit about value-aware AI. She's joining us from Barcelona, and there she is. The floor is yours, Nardine.
Thank you, Samia. First, I want to apologize a bit. I'm a little bit sick, and I'm not myself today. But nevertheless, I'm very happy to be with you here, even if online. You have a very interesting agenda and talks. So thanks a lot for that. Now, in this talk, we'll move a little bit away from the LLMs. You'll have a different take on value alignment in AI. I will start with some motivation and roadmap. There's a short paper that will appear. There's the page online now, but it will appear in a few months with this motivation. So first, I wanted to situate the work. So there's this topic of ethical AI with many different issues to address: explainability, transparency, responsibility. But this specific work is on the topic of human values and how to be aligned with human values. And value alignment is defined as such: how to ensure AI system behavior is aligned with our human values. And when we talk about alignment with human values, we can think about the alignment of the behavior of a single agent or the alignment of the behavior of a multi-agent systems. When we're thinking of a single agent, then the reasoning is about which actions the agent should take, the agent's decision-making process. When we're talking about the alignment of a multi-agent system could be a collective of agents and humans. Then we're talking usually, the work that has been done so far is usually about reasoning about the norms, because norms have traditionally in multi-agent systems been the way to mediate interactions. So there is some work on norms there, alignment of norms with values. But I will say we will go a little bit beyond value alignment. And here I propose the following definition for value-aware AI. We say an AI system is value aware if it can identify and understand a human's value system, it can abide by that value system, and it can explain its own behavior and that of others in terms of that value system. So here we have some key capabilities that should be achieved to identify and understand the human values, to reason and abide with the human values, and to explain behavior from the perspective of human values. And this, in a way, defines the roadmap for us. So in order to identify and understand the human values, we need to work on value representation. How can we formally represent values? Value learning mechanisms. How can the system learn what are our values? Value agreement mechanisms. If you have values of individuals, how can the individuals agree on the values for them as a collective? Then there's the value alignment mechanisms to ensure behavior of single agents or multi-agent systems are aligned with those values. And finally, there's the explainability mechanisms, value-driven explainability. And this raises awareness not just on the agent level and the multi-agent system level. So here we're developing AI that is value aware, but the awareness can also be raised on the human level. So as you will see throughout the talk, we will talk about raising awareness for medical doctors, for firefighters. So the AI can help us humans be more aware of how much is our behavior aligned with different values. Before I get into the details, I just ask very quickly. So now we're talking about values as a new construct in AI. And the question that sometimes is asked, do we actually need to introduce yet a new construct? And this is something similar appeared in Samia's introduction today. You were talking about desires, I think intentions and other things. So here, this is my view on things. I would say there are different motivators that influence our behavior and actions. These motivators can be on the collective level or on the individual level. On the collective level, there are the norms usually. There are as well our collective values as a society, as a group, etc. On the individual level, there's our beliefs, our goals, our values as well. You could also consider new things like traits, etc., my personality, and so on. And it's really a very complex thing to see what is influencing a human's behavior. But traditionally in AI, we've taken norms, for example, and we've tried to make sure that behavior is aligned with norms. We've taken goals on the individual level, and we've tried to ensure that our behavior fulfills certain goals, is aligned with those goals. And you do that by checking the outcome of that behavior. You evaluate the outcomes of this behavior. And what we're saying today is that maybe it is time to actually take values and start checking the behavior from the perspective of values. This doesn't cancel the other things, but it just tells you another perspective. So with respect to values, how much are we aligned with our human values? And it is in the literature one of the main motivators of human values. So I will skip this slide. I will move. Now, the rest of the talk will try to go into the different topics of the roadmap, not everything, but the things that we have mostly focused on. I will give you a general idea of what we've been doing on some of these different topics. I will start with the topic of value representation, how to formally represent values. This is work that I've done with Mark D'inverno. The paper was presented in AMAS this year. And I'll start by the question, what are values? So the problem with values is that until now, in the AI literature, not everything, but the majority of work has been treating values as a label. Argumentation with values is used as a label, like fairness. For us, sometimes as well, the relation between values and norms, the alignment values is used as a label. So the question is here how to formally define values to be able to reason with them. But before we formally define them, we look at the literature to see how they are defined. And you can see this is only a small selection of definitions from social psychology on values. And the definitions are varied, but if you look deeply at these definitions, you'll notice that there are certain aspects that repeat in the different definitions. So for example, on the nature of values, the things highlighted in orange, some people say it's a conception, others it's a belief, principles, convictions, and so on. What are they for? They are to help influence behavior, guide selection or evaluation of behavior, lead a good life, realize good society, and so on. What are they about? They're about end states, modes of conduct, ways of behaving, actions, and so on. They focus on what's desirable and preferable, the things in pink. They are concerned with both the individual and the group, the things you see in blue. So this is our summary from the literature. So we say in the literature, values can be considered as beliefs, conceptions, principles, and so on that guide behavior by considering what actions or outcomes are desirable or essential for either individuals or collectives. Based on that, well, I'll come back to that in a bit. Our proposal for formally defining values is to define them through taxonomies. It might appear a little bit complex initially, but I will argue for this very briefly so that we can talk about other things in a bit. So through a taxonomy, you can capture abstract concepts, as I said here, like fairness, like reciprocity, fair reward, and so on. You can capture abstract concepts. You can capture the relations between these abstract concepts. You can capture their semantics. So if you can look at the taxonomy here, the leaf nodes, the square nodes, are different than the abstract concepts defined by the circle nodes. The leaf nodes are property nodes. They can be defined formally, and they are what gives values their computational meaning. They allow us to do computations with values. So if we take a look at these, the property nodes, this fairness taxonomy is for a specific use case. It's the UHelp app, an application where people can try to find help within their social network for their everyday tasks. They can volunteer and they can ask for help. And one value could be balanced give and take, for example. This is one view of fairness. And you can define balanced give and take as one's help requests are proportionate to their offers for helping others. You can vary it a bit and say one's help requests are proportionate to their actual helping of others. Another issue could be the balanced division of labor. So you can say tasks should be distributed evenly amongst volunteers. And as I said, these can be properties. And this is what makes all of this computational. And then there's another notion, the notion of importance. Not all values are equal. Some concepts are more important for others. It depends usually on the context. And but this is how we capture importance. Here you can see the numbers at the different nodes. I'm giving a very, very general overview. There's more details in the paper, and I'm happy to answer any questions about this. But that's just to give you a taste of how we look at the formal way for modeling values. And in a way, I just want to say here that this is aligned with social psychology. Values here are abstract constructs grounded by goals with importance. They influence, the objective is to influence behavior, as you will see in the rest of the talk, and they can be held by humans, individuals, or collectives, which didn't appear in the taxonomy, but you can have taxonomies for individuals and collectives. And another important context is that they change with context and over time. So nothing is fixed forever. We change our priorities, whether privacy is more important than security. It could change for me from one context to another. So that's it. That's the first piece of work. The second piece of work that I will present here is about learning. What are our values? And I would say this is one of the biggest challenges for the work on value alignment. It's easy to assume you have these values, but to actually to actually capture their semantics properly is tricky. It's not easy. We've worked, as you will see here, with medical doctors. I will talk about this now. Chatting with medical doctors, asking them, it's not easy to try to get concrete answers for them to ask them to give a number on importance or to formally define the formula, the formula describing a value. So it's not easy. So in this work, the people in the second row are the doctors that we worked with, actually. In this second work, we tackled the issue of learning values, learning the formulae that best describes a human value. As an example, I will say, if you take income inequality, for example, you can see the Gini index. It's used by the UN. It's used by many international organizations to describe income inequality. But you can also find in the literature many others. There's the Hoover index, the Thale index, the Palma ratio. Many different formulae can pop up. And what we were trying to do in our use case with the doctors at Hospital del Mar here in Barcelona is try to learn the formulae that capture the semantics of their 4 bioethical principles. So the 4 bioethical principles are the basic values in medicine, basically, and in other fields as well. But beneficence, non-maleficence, autonomy, and justice. And how are we doing this? We're running basically a user study. The user study we have 150 cases, patient cases. For each case, the doctor is shown the medical action that's being performed, the patient status before that action took place and after that action took place. So how did that action change the patient's status? The criteria describing the patient, they are about cognitive decline, for example, their frail index, and different generic indices that can be applied to all patients in the hospital. There are other autonomy-related variables, because usually autonomy is about whether the patient has been informed about the results of a procedure, are they happy to perform the procedure, and so on. So these are the autonomy-related variables. They do not change with the action. You don't have a before and after. And then with this information, doctors are asked to provide input on whether they believe each of those values, let's say beneficence, has been promoted, demoted, or not affected. And we're collecting, now we are in the process of actually collecting this data. This should be closed next Wednesday. And then the plan after that is to have an evolutionary strategy algorithm. We have the algorithm implemented. We're waiting for the data now. But the objective here is to try to search the space of potential formulae to find the formulae that best fits the data that we have collected. The formulae has as variables the criteria, the patient criteria and the autonomy-related variables basically here, and it has the answers that we collected. And then we have a very basic grammar. We can make it more complex if needed, but this is just to get started. And the idea is, as I said, try to generate formulae that are best aligned with the data that we will collect here. Best aligned, this would be captured by the affinity. If we have more than one formulae that are close, then we give priority to less complex formulae, basically. So we also take into consideration the complexity of the formulae, and this becomes an optimization issue, basically. You optimize to find the best formulae here. So this is our approach, or the first approach we're following for value learning. I will move into the next topic, which is value alignment. As you see, I'm skipping value agreement. We don't have much here. We have some colleagues that have been using social choice to help aggregate values to get the value of the collective from the values of individuals. But I will keep this talk light and I'll jump into our work on value alignment. So I will continue. This is another paper, but on the same domain. So here, with the same doctors, we go into alignment. We talked about earlier alignment of a single agent and the alignment of a multi-agent system. And here we're working with doctors. We'll focus on the alignment of a medical professional, the behavior of a medical professional. So here we're reasoning about the actions that that professional will take to help support their decision making. And when we talk about, instead of the multi-agent system, we talk about the alignment of the behavior of a team of medical professionals. And here what we're reasoning about is the medical protocols that they have at the hospital. We'll start with the first one on the individual level. And what we're doing here is we've built a system. Again, we have this now encoded, but waiting for completing the phase 1 and getting the value formulae. So what happens here is the doctors would provide this as input. This is the description of the patient case. Here you can see some example of the criteria: complex chronic disease, short-term survival, clinical risk group, etc. Very generic criteria. Then the doctor would also, in addition to the patient's status, they would provide as input the potential actions that they want to analyze, different actions. And then the first thing we do is to try to calculate the expected outcome of actions by learning from past experiences. This is challenging, so we might skip this initially until we have enough data collected, and try to have doctors tell us their expected changes initially. We'll see how this goes. But the idea is to calculate the expected actions. Now, by learning the criteria after, and we have the criteria before, we can simply here plug in the equations that we would have gained earlier from the value learning phase to calculate how much is each action aligned with each of the values. And we expect to show doctors something similar to this. They would visually see for a specific action, which values is it promoting more or demoting. We do not take decisions. It's up to the doctor then to decide. But this is raising awareness, basically, for the doctors about the value alignment of their actions. So I'll keep it here, very high level. I'll move to the next stage when we're talking about not just an individual doctor, but how things are working in the hospital in general. And here we reason about the medical protocols. We've spent a couple of months trying to decide. They have thousands of protocols. We tried to decide one protocol that might be interesting to analyze, and we decided to go for the NEAT protocol. The NEAT protocol is about the intensity level of the therapy intensity level that would be chosen for a given patient. And the protocol defines 5 different levels. Level 1 is telling the doctor, do everything possible to save the patient. Number 5 is on the other end. It tells the doctor, do everything possible to make sure the patient is comfortable, and that's it. And then you have these levels in between. And the idea is to decide on the NEAT level. This depends on what the patient wants. It depends on what is possible for that case. So the patient and the doctor are expected to sit together and decide together on the NEAT level that's suitable for that patient. And each NEAT level essentially tells which actions are recommended and which should be avoided based on that level. So that's the protocol that we have chosen. It's a simple protocol. It's not complex. So this can easily be modeled as an MDP, a Markov decision process, basically. And what we have from the previous work, the ones I just discussed, assessing the alignment of a single action would allow us to assess such a transition. An action would move you from one state to another, and we should have this now working. And from that, we can build on that to assess the alignment of a path of action by aggregating for the different actions. And then you can aggregate over the different paths, taking the probabilities of the different paths, and then you would be able to assess the alignment of an entire protocol. So this is the plan that we have in place. As I said, everything is, the code and everything is in place, and we're waiting for the formulae to be extracted and to test them. We've tested it with synthetic data, but we're waiting for the real data. So that's it. That's one application domain. There's another ongoing application domain that's also very interesting, also focusing on value alignment. It's not published yet, but I thought it would be nice to mention here. This is work done in another project led by Jordi Sabaté. And the project is focusing on using agent-based simulations to train firefighters. And the firefighters got interested in our work on values. They told us that, the value systems for firefighters can change drastically from one country to another. Different cultures would have really very different value systems. And as such, the question was, students would also come in with their own value systems. So when using the simulation to train students, the question was, can we also train the firefighters so that their behavior becomes more aligned with the values of their fire department? So we use the simulation not only to train them on the different aspects, how to follow protocols and everything, but also to consider values to make sure they are aligned with their fire department's values. This is a very similar thing to what I presented above for the doctor's medical use case. We're focusing here on the firefighting domain. So it's also an MDP. We define the states and actions here. These are different. Earlier, the state was about the patient state. The actions were the potential actions the doctor would take. Here, the state would talk about the fire intensity, the occupancy, how many people are in a given level or room, etc., the equipment readiness, the visibility in a given space, the firefighter's health, which all of these would change over time and with different actions. The action space that we consider here is whether one should evacuate occupants, contain fire, perform aggressive fire suppression, take their time and plan with other agencies, or pause, assess, and plan. So this is the action space, this is the state space, and then we move to define values, and we do this, I say manually, but we actually use the ChatGPT. What I mean here is that we don't have the funding to run a user study with the firefighters. They don't have enough time, etc. So we use ChatGPT to help us to define two values. So this is still a toy example. We have here two values, professionalism and proximity. And what ChatGPT helped us with is for each one, it would tell us how different actions would actually promote or demote each value, promote it a lot, moderately, not at all, and so on. So these are the values. Now we have the states and actions, we have the values. What we can do next is calculate the alignment of a path. With the values, we can calculate the alignment of one jump here, but then we can calculate, as before, the alignment of a path, and we can also find for the optimal path. So the outcome basically would be the firefighters training, and then at the end of the training, they would receive two kinds of feedback. The first feedback would, as before with the doctors, they would see how much were they aligned with different values. And the other thing is we can actually tell them what is the optimal path to be aligned with their fire department's values. So that's it. That's the second use case. There is more work on alignment of norms or policies. I will not get into the details of this, but very quickly, just to give you as well an idea of what else we are doing, because the application domain is also interesting here. So Alba is a PhD student. Georgina is as well her co-advisor. She's a social scientist. And the topic here is to evaluate the impact of various policies on poverty. The value we want to promote is to minimize income inequality. We defined this through the Gini index, and we tested this in Barcelona's metropolitan area. And this is basically what we have in place. We designed agents. Well, we have agents with different profiles. We got existing data to try to populate the agent profiles. We defined some agent actions that they could do in the city: go shopping, buy groceries, go to the movies, etc. we used the needs-based model for selected for the decision making basically. This is based on Dignam's work. And then we selected with some NGOs here a number of policies, 6 basically policies. And we tested the impact of each of those policies, and we also tested the impact of the policies altogether. How would they affect at the end the income inequality? I won't go into much details. This is just to give you a sense of what else we are doing. And I will stop here to leave time for questions. I will just, before we start with our questions, to close, so you don't feel lost with the number of things I presented, I will say basically here I presented what the definition for value-aware AI in our view, the roadmap it resulted in. We've presented initial work, a proposal for value representation, initial work for value learning, some of the work we've been doing on value alignment with real-life applications. We haven't done much on value agreement. We're in the process. And we haven't touched explainability yet, so we hope this would be as well the next step for us. And that's it.
Thank you, Nadine. Do we have any questions from the room? No questions. I have a question here. I wrote it on the paper so I can read it. So there was one question asking, how do you map actions to values, and how transferable are such alignments? And are they tied to the values of the subgroup that was your target, or can it be generalized to other groups? This, I think, is related to the medical domain.
To relate values to actions. So basically, I will go back to, where was it? Here. So what we were trying to do, well, first I will show this, to go back to this. To income inequality, for example, you take, the equation is based on the income of different, I don't know, households, people, etc. But different incomes, basically. These are the variables in the equation. And it tells you whether you have the level of income inequality in a country, basically. For the medical use case, if we take beneficiency, for example, beneficiency is about whether the action performed helped the patient or not. Non-maleficiency is whether it harmed the patient or not. So you can imagine the criteria that would be relevant are these, the state of the patient, whether it improved or not for those two values. So we are trying to look for the formulae that would have these variables as its parameters, and basically it would be an equation that would tell us how is alignment, when is alignment achieved with those parameters. I don't know if this is making it clear or I'm not explaining myself properly.
I think it's good. Thank you.
Okay.
There are 2 more questions.
There was another question about the group, if it's for a specific group, or you can. So actually, we're running this with Hospital del Mar. We started, even before running this use case, we started working with just the 3 doctors that appear there in the list. And we actually came up with some equations, which criteria are important for beneficiency, etc., and which criteria is more important, and we designed it. But then we thought we wanted to capture values for the entire hospital, not for those 3 doctors. Now we're contacting another hospital that's interested in running the user study for them and try to find the formulae that best describe their views. And it would be interesting to see whether these formulae would be similar or not. And I don't know here. So, but this is something we're considering as well.
Yeah, great, thank you. There is one more question.
Okay.
Thank you for the interesting talk. I have a question exactly about this slide. The functions you here try to find that express values, you have condition 2 says that you're also looking at the complexity of these formulas. What would be the motivating reason for that? Because there could be many, like you want to be as brief as possible, or maybe you want them to be as understandable as possible. But let's say from a value perspective, what would be the motivation?
You're right. You're right. Here, the objective was to try to be as clear as possible if we want to go back and explain the values to the doctors. We have this now because we started with another use case actually in mind, where we had a study, we ran it with the participants online to tell them about their behavior when allocating things between two different groups on whether they were respecting equality or not. And we thought going back to those users, having something clear was very important. So complexity was very important. In this specific use case with the doctors, as this is still ongoing, we might drop it, we might give it less importance. So as this is still ongoing, it might be less important here. That's what I want to say. So maybe you're right.
Okay, thank you.
Great. One last quick question.
Thanks, Nardine, for the presentation. So I also have like a question about like this particular study that you are showing on the slide. If I recall correctly, you mentioned that each of the doctors are like doing this exercise for like 150 cases. And I suspect that the human bias will be in this as well. And when it comes to the part, once you have the data, like try to understand what is like the best function ever to represent this kind of thing. Are you also like considering to have some interviews with the doctors to like understand their choices? Because I suspect that they will not agree when a particular value is like promoted or demoted in a specific context.
Yeah, it's a very, very important question. It's a big challenge. What you mentioned here, it's true. When we were chatting, because we started with a few months meeting every 2 weeks with the doctors, discussing with them for us to try to understand, and we came up with a few equations. But yes, when you see the discussions, I mean, one case, they would spend half an hour discussing it amongst them. And we taking notes and asking them questions to try to extract what's more important than what, etc. So I fully agree. It's not easy. Not only that, they're extremely busy. Running this user study has not been easy. So we don't have each doctor answering 150 cases. We're trying to have 20 doctors/nurses, each one assessing 3 cases, to get more varied opinions from different departments and so on. Is it enough? I would love to get more. It's a challenge to get more, but it's something to start with. We will have meetings after that, yes.
I'm also wondering like what it will be if you conduct this exact same study as an online study and like, look at like a more diverse.
Yeah. The thing is here, online study, you want professionals to answer this. If anyone is aware of a place where I can get the doctors to answer this, I would be very happy to try that. Let me know if you're aware of any online site. Yeah.
We will think about it. Thank you, Nadine. Thank you so much.
Okay.
Now the next speaker. Are you ready? Yes. Yeah. There is a clicker. Cool. There is a clicker, yes.
Hello, everyone. Hello. How are you all doing? Yeah, cool. So, I'm very happy with that last question, Nadine, because now we can seamlessly move into what I'm going to talk about, which is a lot more to do with the problem of people being the issue behind anything we want to make critically useful within AI or robotics in the extended sort of universe of advanced technologies. So I'm going to talk about my experiences in lots of different domains with human interactions, lots of different kinds of societies, lots of different countries, and the implications those social groups have had on all of the robotics and AI research I've tried to do. Now, I'm going to start with a nice colourful slide, just to you don't have to read all of this. So I normally, when I'm doing guest talks for a mixed audience or an audience of students, I will describe a bit about my background to explain how Non-traditional routes to becoming a roboticist are fine, everyone does it, look at this madness. As you can see, we've seamlessly moved from philosophy through to robotics, with a period as a translator in Japan and pig farming. Why wouldn't you? I was a translator. I worked in international politics for a long time. And then I retrained in neuroscience with the hope of doing dementia research. It turns out there's not a lot of money in dementia research. People don't like the elderly, I guess. I don't know. God, it's awful. And I ended up doing computational neuroscience and moving into robotics in that way. And then I got to sneakily do a lot of healthcare stuff whilst taking money for nuclear decommissioning. Seamless career. Now, I work at Manchester University, where I'm a full-time member of staff, but for these 5 years, which I've just started, I get to focus just on research. And my work is all about looking at how to build robotics and AI systems that become trustworthy and responsible across a whole range of domains. So I still work with nuclear decommissioning sites across the globe, but I do a lot of stuff in different healthcare technologies, rehabilitation robotics, oil rig maintenance, what else? I'm still building tiny animal-like robots when I get time. So I did a period in biomimetics where I was building brain-based robots based on guide dog puppy development, actually. That was just an excuse to get funding to play with puppies and robots. Oh, it's seamless career. Right. So the point is, even now, sort of based in computer science, doing robotics, I can't help but wonder on the issues that we have in these technologies when they go to their end-stage deployment, and all the issues that suddenly arise that were not benchmarked in the lab, to me, seem very obvious because of these human interactions that occur that get in the way of, that are the reason we're trying to have advanced technologies, right? To be a better society, utopian future and all that. I've only got 25 minutes. If it was longer, we'd go dystopian, but, you know, let's keep it light. Right, ethics then. So, human values and AI. What do we want to talk about? We want to talk about morality and ethics and the legal and social parameters of that, how they differ across countries, all of these things. But oftentimes in engineering, when you're asked to talk to the engineers about ethics, these questions don't come up, which is, what do we really mean by that when we design something, develop it, and then deploy it, hit issues that we probably would have thought about in the design phase if we understood this issue of human people and their values. How do we measure that? How do we measure context? How do we predict changes in measurement? How do we predict how different a piece of robotics or AI technology is going to be used in 10 years when I can't tell you even what kind of materials we'll be using to build robots in 10 years? So all of these questions that apparently, to be efficient, positive, value-focused human developers, you kind of need to consider if you want to produce a really good, effective piece of robotics or AI. Obviously, all of this is an impossible question, which is why interdisciplinary teams are so vital. Right, yeah. So when you're dealing with engineers, you often kind of, how do I write a line of code that does trust? And then we can tick that box and move on. So that comes up quite a bit. And if you ignore the complex issues that cannot be solved within an algorithm, you get an end product that is not used. So what I'm going to talk about for the rest of this is, what's on the next slide? Yeah, okay. Is experiences I've had doing studies, trying to deploy and test bits of algorithm, bits of advanced technology, robots, in a whole range of different industries that ultimately had the same problem, and how I am now using that to work around a model of these extraneous variables of human interaction that if we can consider at the start point of design, even if you don't quite know where that's going to go, it becomes very helpful for long-term deployment. So I'll start with a couple of issues then that I want you to think about as we're talking about these case studies I'm going to go through. Who is responsible for the use of technologies, So AI, robotics and AI, advanced systems, and more importantly, who is responsible for the consequences of their use? So we talk about value-aligned technologies. If my value is money, money, cash, cash, all for me, please, thank you very much, utilitarianism of one, then the consequence of a use might be, I don't care what the technology does to everyone else in society. If I'm making money, I'm value aligned with me. Brilliant. If something goes wrong at some end, am I responsible, or can I step away from that and blame the consumer? And depending on which country I'm trying to sell that product in, which law am I going to have to align myself with in order to avoid jail time? Keep it light, keeping it light. Issue number 2. Why do we see a shift in baselines then, obtained in the lab in your development and design phase, to those that we then see in the real world? So what I found was you'd build these wonderful state-of-the-art big robotic projects. So we're talking about, huge stuff like maintenance robotics for the use inside experimental fusion reactors. That was a long project I worked on. Or the advanced toaster we discussed yesterday that doesn't exist yet, but would also cut your own bread. You test these things in a really nice, clean setting, and it's fine, and then you deploy it, and for some reason, all those efficiency measures are not the same anymore. And it's not the problem of the technology. Again, it's people. It's people. It's people. So, nice big slide with these issues. So you've been given a nice big fat amount of capital investment for whatever you're doing. Huge upfront investment. Rehabilitation robotics is a really good example. You have a lot of people that want to pump money in, the money people. Let's build a big shiny robot. Let's build a fantastic algorithm that will solve all these problems. Develop it in a lovely, clean lab. Maybe you've got some really keen students or some interns that are very happy to ensure that you know that they like you, and so they're telling you that the robot is perfect and it's all wonderful and shiny. There's no risk from implication. Indeed, if the students are more positive and receptive, they're less likely to lose their jobs, right? They're more likely to engender themselves to the professors who love themselves, shut up. And then you have the pressure to produce an engineered solution within a time frame as well. So all this stuff's happening, capital investment, build, money, money, cash, cash. Pop it in situ, done, right? And then suddenly, these huge rehabilitation robotics kits, it's a very good example. So this is the last big one that I did. Then end up sitting in these clinic spaces as glorified coat hangers, unless someone who has invested and is your manager comes by, and then you're using it actively and everyone's there for a photo shoot, of course. But ultimately then, you get this huge resource waste, not just of capital investment, but of materials, lithium. Oh, we've got so little left. Again, dystopian future, but keeping it light. A distrustful workforce. So now you have people raising the question of, okay, so you're inserting this stuff in here, but what is this thing here doing? Transparently, I don't really understand the algorithm because I didn't build it. You didn't consult me on what it was going to do. Are you hoping to retrain me? Am I going to get shifted away? Is the robot also, for some reason, tracking which of the workforce is working most efficiently with it? And then the people that don't work well enough with it end up losing their jobs. And so you get a lot of unreproducible data, right? And then ultimately, of course, again, depending on where you're working, what legal parameters you're working with, you get unclear repercussions upon failure. Going back to issue 1, if that happens, who is responsible? These are just loads and loads of questions, by the way. There's no answers to all this, other than humans, right? So, why then, this is the question, do some technologies, and again, we can talk about AI or robots with a nice piece of AI algorithm inside it, but why do they sometimes, at this endpoint, fail at being deemed responsibly used, deemed as irresponsible by the user to use them for a variety of reasons, lots and lots of questions, fail at being seen as trustworthy. We can consider trustworthiness as an objective value that the thing might have. whereas trust might be a subjective opinion that I have. These two work in tandem, right? To the extent, therefore, that there's so much uncertainty, I don't know where the values are aligning anywhere along the train, that it just goes unused, unless, of course, there's a photo opportunity. And why do I argue, therefore, in part at least, because there's always more than one answer, right, is all of this rooted in these mediating human interactions? So, a lot of it has got to do with the next two slides. Big questions, yeah? So we've got this cornerstone of subjective trust in understanding what we think about robotics and AI, is the discussion of responsibility and transparency. And that is built around this idea that it's much harder to use and therefore especially trust. Oh, it's down here as well. Oh, I didn't. Efficient. Robotic systems that have opaque decision-making processes. So the word transparency, a lot of these keywords, by the way, depending on what discipline you're in, or if you're even a policymaker or you're writing BSI standardizations, will have different definitions depending on who you're talking to. So we use words like agency and responsibility and transparency. If you're a philosopher, if you're a lawyer, if you're a computer scientist, these will have different meanings. But transparency is a really good word, right? Because something can be transparent because I know the extent to which the algorithm is telling me what's going on. But something can also be transparent to the extent that I know enough about what's going to happen to me personally and whether or not I can feed my family next month upon using this kit, because whoever's given me the piece of kit is being transparent with me. So there are two different ways that you might think of it socially and from an algorithmic perspective, but ultimately have the same meaning. I'm just saying that because people often get caught up on definitions, and that's a waste of time because it's the end of the world. Come on, guys. Anyway, opaque decision-making processes, right? We don't want that. This is what a lot of people are thinking all the time then. So everyone who's engaging with these robotics and AIs globally, in workplace, in our day-to-day life, because the government has given us a QR code that we have to use. If the person hasn't built it and maybe doesn't have an understanding of what's going on in that algorithmic process, all they really are thinking then is using this going to be something I can believe, trust in, is working with my best interests at heart? Or is there something more nefarious going on? And again, right, depending on what country you're in and what legal framework you're working in, or even the cultural situation of your workplace, the answer to that is going to drastically change. And so it will drastically change how efficiently you're using that algorithm, advanced technology, and that is where the beginnings of these benchmark shifts are happening, right? So, technological systems then. We've been talking a lot about AI today, but because I work a lot in embodied robotics as well, I like to think about technological systems, especially now that I'm including models of human interactions in my initial development phases. Because for me, therefore, this advanced technological system includes the people. Oh God, it's still down here, sorry. I'm getting over a cold and I cannot think straight at all. Yeah, anyway. Don't know where I am. Norway, right? We're in Norway. Good. So the technological system includes the people building it, the people deploying it, so that's buyers, managers, governments, institutes, your boss, your mum, and the people using it, the people beneath them, right? So it's this ecosystem around the technology that we need to consider when we want to answer the question of, why is this technology seemingly not aligning with what I believe the values of my workplace, my people, my humanity to be? Why am I not using it? And this is a huge ask for an engineer in a lab who's just trying to build a thing to make some money, to pay their mortgage and feed their kids next month. Oh yeah, that's great, have a nice life. But at the same time, can you consider humanity? It's just, it's difficult, it's a tough one. I'm going to step away from that over here. Let's talk about mental health. There we go, keeping it light still. So imagine you've got a friend. Everyone, yeah, good, right. It's not just me. Good, excellent. So I'm picturing a friend. And I've gone to my friend because I'm aware that they've seen a counsellor previously that helped them through a difficult time. And they raved about this counsellor. Let's call them Dr. Collins for the sake of argument. And I'm like, can you give me the card of Dr. Collins? I would like to go and see the same counsellor. I'm also having an issue. I think they, based on what you've told me and the fact that I really like you because you're my very good friend, I think that I could get some benefit from that. And so your friend says, yes, this is her card, this is where she is. And you go along to see Dr. Collins, and she's there with all of her advanced degrees, being your tool for the betterment of your own mental health. Fantastic like to see, right? But now imagine, this is based on a true story, by the way, redacted. If you get some wine in me, I'll tell you what happened. Now imagine you've gone into work one day and your boss says, hi everyone who I really like. Hi, I'm your smiley boss. I've decided to give everyone free counselling. Yay. So you're all going to go along and see Dr. Collins, and it's fine. It's just because I really want you all to feel better in yourselves. Now say that that's also happened the same week that you're aware that your redacted institute is going to make some redundancies next month. Now you go along to the same counsellor in her same office with her same advanced degrees, and your interaction with that counsellor is going to be very different. The person who has deployed the counsellor for you is the person, the relationship with, wait a minute, again. Okay, so the relationship with the person in that second instance is very, very different to the relationship with your buddy in instance one. But the scenario itself is identical. But the outcome measure of how good Dr. Collins was as your tool to better your mental health is going to measure very differently in both scenarios. And if you're only looking at one or the other scenario, in the first one, you might think Dr. Collins is great at her job because the outcome measures were great. And in scenario two, if we're still only looking at the outcome measure of how happy or content or feeling of betterment the person had when they left that counsellor's office, it's going to be completely different. And again, because you don't want anyone to know what's really going on inside because of this scenario, someone will say, how was that? And you just might, oh, it wasn't great, she wasn't great, but it's fine, you know, poo-poo. So the answer might be focused very much on Dr. Collins in scenario two, but the real answer is, I hate my boss, oh my God, I don't want to lose my job, got to feed those kids, you know. The tool in the middle, your counsellor, is representative of all of these algorithms and robots that we have to help us in our day-to-day lives. They are the apps that our government gives us to say, hey, everyone, this is going to make your life better. All I need is a few medical details. Oh, no, ignore the new laws that we're bringing in about how we're going to divide you all up in what we learn about your medical background. That's fine. Okay? Versus, your buddy is building an algorithm in the lab, and you're going to make a great game out of it. Maybe the stuff under the hood is identical, but the scenarios going on around it are so complicated, involving those pesky humans and their varietous values, which are not always going to be based on beneficence, that you're not using them in the right way. And so we'll end up dismissing these fantastic pieces of technology because we are not appreciating that the actual problem in aligning our technology with our values is not the technology, it's people. And again, this is, I can't help it. We're just going to get dystopian now for the rest of this. It's fine. That's what cheese is for. You eat the cheese, you forget about dystopian. So in order to start to build this idea, which is very big and high level, I do appreciate that, into any kind of study that involves you wanting to test a baseline of a piece of technology, I just whacked an extra bubble onto my standard models. So normally within human-robot interaction or agent-human interaction studies, is there a little laser? Oh, yeah, cool. So, okay, there you go. You got your person, whoever they are, your bit of technology, and then you get something to happen and you measure it, and this measurement tells you, is it good or bad for this person? Is this good or bad? Done, bosh, sell it, money, money, cash, cash, right? And then things go wrong. So all I've done is inserted an extra consideration level into this model that says, who has made this happen and why? So a deployer, again, we're talking about a whole stack of different people. And in fact, one of the reasons healthcare technologies are so fascinating for this model is this is then layered. So in rehab robotics, you've already got the baseline of trust between a clinician and their patient. But then you've got the clinician and whoever their manager is, and the clinician and whoever the manager's money person is, which might be different depending on what healthcare system you're in as well. Is it government-owned, or is it based on capital investment and money? And then the piece of technology is almost secondary to everything else, because ultimately the clinician, regardless of what tool they're given, wants to pay their mortgage, feed their kids, and make sure that the clinical outcome for their patient is best with whatever is going on here, be that their skills or a piece of technology. So just to simplify that then, this is your standard HRI study, or test a piece of robot, test an algorithm study. So we're adding on some deployers who might direct the piece of technology with whoever's programmed it, whoever is given the instructional aims for whatever this bit of measurement is. And then you've also got this crucial bit over here, which is the relationship going on between whoever this is, whatever this is, wherever this is, and whoever this is down here. So the context within which those instructions are being deployed and what those instructions are, based on what you might understand the repercussions to be if something bad or good goes on here. Yeah, that makes sense? Yeah, we're getting good. None of this, yeah? Okay, great. So there's a paper which makes much more sense than I am right now, by the way. And that's kind of what you get. So you end up with a bit of measured AI in the middle, which now allows you to appreciate why this context is going to change depending on how this is shifting. And this particular paper here, which was published last year, covered a few case studies of what at the time were disparate assessments of deployed technologies in a range of different industries that my team and I conducted over quite a few years. And then the pandemic happened. Again, keep it light, Emily. I sat around in my living room in my pants. I mean, fully dressed in a lovely suit, and not at all just in my underwear. No one did that in the pandemic, right? No, just me. Great. And I was sort of looking at all of these different papers and thinking, the outcomes of all of these papers are the same. And that's where this developed from. So we looked at all these case studies, and we started by looking at the differences in who all the deployers were, and how that shifted the differences in who all the participants were, and what that meant for the outcome measure of the bit of robot being deployed. All of the case studies involved a very similar sorting task, deployment of robotic arms that were based on the same algorithms and technologies in different kinds of industrial settings. So essentially, the task that was being measured was kind of the same, depending on where the robot and the situation was taken. The first one we'll call our baseline, right, is your typical, we set it all up. We set it, is that including questions? Oh, cool, right, great. So we set it up within the laboratory in the university or your institution, so your normal kind of setup. And so your deployers were simply whoever, in this case, it was Sheffield University in the UK, the researchers were the deployers, right? And we had a bunch of staff and students who were already on mailing lists to come and play with robots, who were very, very happy. So this relationship here, everyone's in the same in-group, they feel great for supporting their university, having a jolly old time, there's bickies afterwards, it's lovely. And then this particular study, we were testing the algorithms on a large-scale KUKA that might be used within an industry complex anyway, and we kind of were looking at your basic measures that you might have during a sort cobotics task. So speed, effectiveness, efficiency. There was opportunities for both qualitative and quantitative assessment, so this whole making sure you were asking people how frustrated they were if things went wrong, looking at dangers, asking people about risk and reward, and then just the speed with which tasks could be done and the failure rates. Great, everything worked brilliant. Time to take it out into the real world. So the first place that we went to was a small-scale factory in Yorkshire that was family-run. Plus, then, you get used to tiering of deployers at this point, and us as researchers as well. So we went along with the assertion that everything was going to be okay and anonymized and everything. But already, of course, it doesn't really matter what we're saying, because now there's a level above us. But in this scenario, because it was a small factory, even though the workers weren't unionised, they all felt very happy together, and there was a lot of communication from the management with all of their employers about how they were going to be involved from step one on what would happen if these arms came in. They were really worried about the safety of their workers, and the workers believed them when they were told that. So a lot of workshops to begin with. And in these workshops that happened over here, the machinists were quite free to start to express their concerns. They were a lot more muted than your normal, oh, it's taking our jobs kind of thing. They wanted to know about restructuring, how that would work. They wanted to know the consequences of using this arm and what would happen if it failed. Would they be blamed if there was a problem in the production line? If someone got injured, who's to blame? Where's the responsibility? And if the managers gave them appropriate information, they would feel more inclined to use this, and it was fine. Now, this sort of study I've done in a lot of other scenarios, nuclear decommissioning, again, redacted. So sometimes you think it's fine, and then the robot or the piece of algorithm will mysteriously get broken because everyone's saying it's fine, but really they don't trust anyone. And the only way you can really learn that is if you give it time and then observe as things are going wrong, but they're not really going wrong. It is just complete reticence from the users to get involved because everyone is lying. Oh, it's very bleak. Anyway, if you want super bleak, case study 3. The problem of dealing in the real world and doing in situ studies, I find great, but you have to give yourself so much time to do it because not only is it hard to recruit, especially in healthcare, right, but you're going to have problems at every stage depending on what's going on with the social interactive construct. So, redacted aerospace company. Yep, I have taken it all off. Brilliant. Aerospace technicians. We rocked up. They were already very, very used to using robotics and algorithms within their work. But we arrived with a huge workers' dispute and a union strikes, and it went on for years. This never got off the ground because of that. But every time you ask the technicians, what do you think about the robots, they would at least say, yeah, they're fine. I'm not using it, though, because I hate these guys. So at least at that stage, because they were so engaged with themselves and so focused on what their value was, which I want to pay my mortgage, I want to go home and read my kids at night. I did a study where they were trying to introduce new virtual teleoperation work within nuclear reactor decommissioning. And they were trying to introduce this new algorithm that would make it easier for the workers. And I was there during the trial phases. I remember this one technician who was only using it maybe 45 minutes a day to test the algorithm. He'd be sweating, the focus was intense. At the end of the week training period, I sat him down just to talk, how was that then compared to your normal daily life? And he said, I've not read to my kid every night because I've gone home exhausted, and then I've not really slept well because the immersive environment just doesn't resonate with me. If they introduce this into my workplace, I mean, I love my job, but where's my work-life balance gone? Where's me seeing my kids every day? The money people that want to invest in this flashy new hardware are not really interested in these questions, and they spend all this money and wonder why it doesn't work. Anyway, cheese, everything's fine. Yeah. And so now when I'm sort of trying to build a piece of technology or working with new researchers or talking to PhD students and trying to be upbeat and not at all saying, oh, you want to be an academic? Oh, you don't like money. I see. Yes, excellent. I kind of start with, if you want to build something that's effective and efficient and you're thinking about what is an ethical algorithm, don't put all the onus on the algorithm and the AI. Think about the human relationships that are going to happen at the final stage with these people, their employers, their government, how you're going to get it through standardization and policy anyway so that these people can use it and know with clear transparency what is going to go on when it goes wrong. And it will always go wrong to some level. So all of these factors are not consistent. And yet we're still pushing for these technologies, right? So I especially, going back to COVID again, this big push to have more technology in our life, in my opinion, we're just creating a bigger social gap in the inequalities that already exist globally. If you make a piece of technology essential to a daily life of a normal person, but not everyone has access to that technology. I'm looking at you, laptop that works for student that has to, study virtually. You're just creating inequalities. Someone once asked me, how do we solve the problem of, dark... Thank you, dark problems. Just algorithms destroying people. You're looking at the wrong thing. It is not the algorithm. It's the people not letting you see what's really going on. If we increased global childhood literacy rates, a lot of our problems would disappear overnight, right? Because people would have the knowledge and power and understanding to know when they're being screwed over by someone trying to sell them something for the betterment of themselves, because their value is me, not everyone. I'm getting very socialist now. I'm pretty loving this, aren't you? Yeah, it's a great follow-up to the next talk. So, we should be asking every time we're thinking about AI and robotics in the real world, who is responsible when the technology fails? Is it going to be the employer? Is it going to be the deployer? Is it going to be the user who's been instructed to work with the technology by the deployer? And just even if it's really hard because you're an engineer and you don't want to be thinking about people, just find someone and bring them into your team who can raise at every point in that development phase. Let's just try and understand these subjective pathways amongst humans in these systems so that we're one step closer to being able to answer all these difficult questions of AI, human values. How are they going to mesh onto each other when everyone's value is so disparate and the world is quite bleak? It's the end of my talk. That's it. Thank you.
Right, we have time for one question or two. Any questions from the room? Yeah? You will get the sticker later.
Thanks for the talk. So you're focused mostly on the relationship between the manager and then the user and the technology, but are there other relationships that could also affect deployment in a similar way?
I mean, yeah. So again, healthcare apps are a really good one. So everyone has their own individual sense of what they value in the world, and that'll be different between what they say to other people and what they're thinking inside. So again, you've got to think about the transparency of those values anyway. So it's not just what you think about your manager. It might be what you know about the industry that you're working in and whether or not it's due for failure anyway. So I've done some stuff with unions. Contract law, so say you work in a factory in Michigan in USA or a factory in Berlin in Germany, and you already, doesn't matter what your manager's like, you work under different contract laws, knowing what will happen, even if you raise a hand to say, I don't agree with what's happening here, it's going to be treated very differently in both countries. Or in the case of healthcare technologies, if the push is, you have to use this technology because we're based on a what's the word where you make money? Again, I'm an academic, I don't know these words. If you're based on a capitalism structure and you're trying to sell to make profit, that's it, there we go. Versus so the NHS who are like, oh, it's pricey, it's much easier if we just sit people down and talk about them. You're getting these shifts and they're just based on what country you're deploying in. So you're going to have all of that deployer work across lots and lots of different people at the same time, which doesn't make it easy. You need brilliant minds to solve it, like everyone in this room. Yeah.
Great. We have one more question there.
Yeah, that was great talk. I enjoyed it. Thanks.
Thank you.
I was curious because you alluded a couple of times in your slides to sort of, if we push for the deployment of technology in every sphere of our sort of life and society, who, in your opinion, is this we pushing for the deployment of society? Like, who's the agent?
You know they didn't land on the moon, right? Yeah. Again, okay, so in rehabilitation robotics, you might have a hospital manager who has been told they'll be given a grant if they buy a robot with it. So in that situation, it would be the money person. But then that goes down to the clinician, and then the patient thinks it's the clinician pushing it on them. If it's just a government and there's a push to stop touching hands, it might be because they're telling you to use QR codes. It might be because you've moved into a house and everyone insists on using one particular DM app as opposed to another, but you don't believe in the values of the owner of that. What was your question?
That answers it.
Cool. Again, it's all of it and everything.
Nice.
The world, let's eat some cheese. This is great. This is fine.
Okay, we take one more question from an anonymous person. You've mostly focused on the relationship to the upper management. Are there other relationships you haven't mentioned that could also be... What? That was your question. You're not anonymous anymore. Well, no more questions then.
Brilliant.
Lunch.
I mean, I've really enjoyed this. Thank you.
I hope you are happy after lunch and ready to listen to more talks. The next one is by Vinit, and the floor is yours.
Is there a clicker or something that I can... Sweet, very nice. Okay, cool. Hi, everybody. Thanks for staying after that excellent lunch. My talk follows very closely to the last talk that Emily just did, so thanks, Emily, for like the smooth transition that you've provided me, because this is a talk about money, money, cash, cash. I'm going to talk a bit about like generative AI, but I'm going to, like, my goal here is to sort of demystify the social relations behind generative AI, right? Like, whose labor's being crystallized into these models, how are they being deployed, a slightly critical examination of these models in a context where we don't have to think about other issues like bias, right? Like, let's imagine a hypothetical scenario where you've got like perfectly fair models, they generate perfectly fair things. What are the problems that we would then see with how these models are sort of constituted, how they're deployed, and how they're used? We all know that there's loads of problems with generative AI, right? Like, we see headlines like this pop up every single day. Like, genuinely, I open my phone, I open like whatever news app I'm using. One of the first things that I see every single day is a news story about something bad that's happened in the whole space of generative AI. A lot of people worry about this. If you talk to the average person, you know, get on your bus, get on a tram, and ask someone what they think about generative AI. And they're going to be, like, people are mostly quite worried about it. They're worried for their jobs. They're worried about things like their privacy. People want assurances that these models are aligned with their interests, right, with human interests. At the same time as we're seeing headlines like this, we also see stuff like this. Governments, corporations are all heavily sort of leaning into this. It's like a huge thing, you know, like, we love generative AI. We're going to unlock unlimited economic potential. We're going to unlock unlimited money, money, cash, cash. It's very good for you. Please adopt it in every single sphere of the economy. You know, like, we're going to save. Yeah, at the same time, you also see, like, you know, these assaults on like state institutions that try to regulate things. So there's this huge sort of discourse in Europe about how Europe is falling behind the United States and China because we regulate too much and because these models need to be unleashed for the productive forces of European capitalism to like compete with our neighbors. So my goal in this talk is going to be try to like demystify all of this, like I said. And I believe that to do so, we need to analyze the systems in which these models are created. And that system happens to be capitalism. So what, like, to truly understand what this means, we need a sort of abstract understanding of what capitalism is. So we can truly start to demystify the relations that go into a very specific technology that has developed under capitalism. Fortunately, we have this book. That cover is not the original cover. But fortunately, we have this book that was written 150 years ago that talks about it. A lot of things have obviously changed since then. And it's important to remember that a lot of what Marx described in his writings on capital were a very sort of abstract analysis of capital, right? They're not like a concrete analysis of, oh, this firm does X, Y, Z, and this other firm does A, B, C, they're competitive, blah, blah, blah. It tries to abstract away from all of that and explain exactly what the social relations at the heart of capitalism are. Like, what allows the system to continue, what allows it to reproduce itself, how value is created, you know, these sorts of things. I'm going to try to summarize 3 massive 1,000-page books in one slide. This is going to be very difficult, so I'm just going to give you like a very sort of broad overview of what this idea is, and then talk about like some sort of modern interpretations of it. So one of the fundamental sort of definitions, one of the fundamental sort of birthing moments of capitalism was the enclosures of the commons in England, where you sort of, you know, you had European feudalism, where you had kind of, the peasant would go to work on the land, the peasant's landlord would say, hey, I want turnips, I want potatoes. He'd send his men, the men would confiscate the potatoes, the peasant is unhappy, but the landlord is happy, and that's how feudal sort of power kind of reproduced itself, through violence. Capitalism introduced a complete dependence on markets, and this is also part of what caused its sort of revolutionary kind of massive growth in societal progress, you know, that sort of thing, innovation, blah, blah, blah. Because by forcing people into market relations, capitalism removed this direct element of violence. It removed the direct threat from your overlord, and it instead turned it into this indirect exploitation by markets. You don't have to like give your boss your potatoes, but if you don't, you're probably going to starve because you can't make your potatoes yourself anymore, right? So it introduces this kind of reliance on markets, and what is important to note is that capital almost becomes like a subject in itself, right? Like capitalists are also kind of beholden to markets. They have to make productive investments. They have to like sort of make profits to survive in this system. So Marx really stressed how both capitalists and workers are kind of slaves to the broader empirical sort of drive that capital itself had. And okay, there's a lot that I could talk about here, but one of the main things that I want to highlight is how Marx viewed value as being created in a capitalist system. And he called it exploitation. And this is exploitation in a very sort of pragmatic sense. I'm not using it in a moralistic sense, like, oh, bad boss, good employee, he's being exploited, how sad. Exploitation is, in this broader sketch of capitalism, how value would expand. And the way Marx hypothesized that this was done is through the exploitation of labor power, which is, you work 8 hours for your boss, you generate 2,000 euros of value. What is actually happening is that you have generated that value in maybe 4 hours, and your firm or the owners or the capitalists keep the surplus value that you've created in the other 4 hours of your time. And through doing this cyclically, this keeps happening over the years, and it leads to a broad expansion of like society's surplus value. And that kind of brought us to the society that we have today, which is obviously much better than 250 years ago. I don't want to die on a farm in the middle of nowhere. Okay, we live in 2024, so there's been a lot of innovations in how people analyze these things. One of the main changes in our lifetimes has been, this digital economy. Everything is about computers. We don't know what a means of production is anymore, like because we own our own means of production. Surely it's our laptops. So a lot of writers have tried to analyze what this means in a contemporary context. One particularly interesting school is a bunch of books that have been written in the past 5 years describing the world we live in as no longer capitalism. One of the most famous voices here is Yanis Varoufakis, who's the former Greek finance minister during the Greek economic crisis, or before the Greek economic crisis. He's also a Cambridge economist. There's other voices like Mariana Mazzucato. Cedric Durand's book just got translated to English, so I could finally read it. But there's a lot of this analysis that in a contemporary economy, capitalists are no longer making productive investments. Everything is about rent. You use Amazon, which is like a platform. The capitalist is not Amazon, but it's the person that sells their products on Amazon. Amazon are just landlords. They provide you a space to sell your products, and they extract surplus from you. Other ways are, things like intellectual property, where companies make massive investments in generating some sort of knowledge of how to make a particular drug or knowledge of how to make a particular artificial intelligence model. And by sort of using legal mechanisms, using treaties, using agreements, they can sort of ensure that they attract unlimited value from the rest of the economy towards the owners of these intellectual properties, right? Like a particularly interesting recent example of this in pharma, for instance, is how much of the Danish economy depends on Ozempic and drugs that Novo Nordisk creates. So the idea that these guys have is that, this isn't even capitalism anymore. We're going back to feudalism. We have a bunch of landlords that run the economy, and any kind of productive capacity that we have is being sort of co-opted by them. It's a great debate that you follow back and forth in the New Left Review, which is one of my favorite journals. And one of the main critique of this whole idea of techno-feudalism has been that you can't call Amazon rentiers because they're investing in research and development. They have a massive R&D budget. Landlords don't need to do anything. They own the land. They kind of just chill out and wait for you to pay them money. Or they kick you off the land when you can't pay them money, which still happens. So this kind of back and forth, and I highly recommend this article, The Critique of Techno-Feudal Reason by Evgeny Morozov, who has some great analyses of this. They also kind of critique this whole notion of capitalism as purely market-based violence. And they point out that, throughout the inception of capitalism, the market violence that existed in England, in the United States, in Germany, was kind of accompanied with real political violence in other parts of the world, right? In the global south. So Egyptian cotton and cotton from the plantations in America would enter into the British mills, and British mills could then sustain domestic capitalism on the basis of resources that were expropriated using, the political power of the British Empire, the East India Company, and the rest of the world. So they're like, when we talk about it being feudalism now, we're kind of whitewashing the whole thing, right? It's always had this element of political violence with it. Maybe the balance has shifted, but like if the balance has shifted, that doesn't make it a new system. It's still kind of the same thing. And we should still call it capitalism and still analyze it as a capitalist sort of thing. I'm kind of making the case, I'm using some of my works that I really enjoy, I'm kind of making the case that we need this sort of expanded sort of viewpoint of capitalism as something that requires both the economic and the political. Some of the best people to do this have been feminist theorists from Italy in the 70s. That kind of became a whole school of social reproduction theory, and also dependency theorists like Samia, who would talk about the global south and how resources from the global south would feed northern capitalism. And the idea here is that capitalism has frequent crises, right? Like it has a tendency towards crisis, it has a tendency towards the rate of profit collapsing, and we've witnessed this in Europe, right? Like this is partially what caused World War II, when markets were just like proceeding sort of full speed ahead until they all collapsed. And the idea behind this is that capitalism thrives on things that exist outside the market. So while it pretends to be all about markets and exploitation in the market, it also requires things from outside the market to enter into the production process. Social reproduction theorists talked about housework and how, in the 70s in Italy and also today in most of the world, to be honest, women would perform housework for no financial compensation, and this would kind of enable their husbands to go to work in the factories and produce value for their capitalists. But this was like a massive input that they were acquiring for free. The same goes for things in the global south, like resources like cotton would continue to enter. In the context of GPUs, for instance, you still have mines in the Congo and in China whose resources are sort of used to build these massive things. And this kind of expanded sort of viewpoint of capitalism is basically that there exists a phenomenon called expropriation that accommodates sort of inputs from outside the market. And these expropriated inputs allow exploitation to happen within market relations. And it's on this basis that I'm going to try and analyze generative AI. I've been talking for 12 minutes, I think, about capitalism, just going on about it. So I probably sound slightly insane, because this is a conference about artificial intelligence. So now I'm going to try, what the point of this talk, it's also based on a paper that I'm working on at the moment, is to kind of try and trace out the broader political economy of generative AI, and to try to analyze what we can possibly learn from these definitions of capitalism, what we can try to conclude or infer from them about how this entire space sort of functions. And in the context of alignment, I want to make the case that we should align with a lot of different things. And one of those things that we should be aligning with is people's material conditions and material realities. So generative AI, broadly sort of simplifying, I'm guessing people here generally have some sort of familiarity with AI, especially because the last few talks have been excellent on that. You require data to train these models. You require code, like as programmers writing these models in Microsoft and universities and stuff like that, and data feeds into it. You then deploy these models to use them in a certain context, I don't know, ChatGPT is ultimately a model that's being used. And both these things, both the training and deployment, require physical devices. They need GPUs, because that's what they're sort of trained on. How can we analyze all of these components? In the interest of time, I'm going to pick out my favorite components and analyze them. There's more on this in the paper, which should be out in a few months, but I can't condense all of it into this. So data, supposed to have a transition where this would come in later to be slightly dramatic, but I think I forgot to put it in. Internet data is one of the fundamental building blocks of AI, right? We know this. These models, maybe 95% of the data that they're trained on is kind of just stuff that's been scraped from Common Crawl, corpora Common Crawl. In the context of image models, it's data sets like Lion. LLMs and generative models require insane amounts of data, and they get this from the internet. People have kind of been hey, you know what? That data was created by humans. That's what makes it so valuable. How do we analyze this, right? And there's a whole school of people that view users of internet platforms, users of platforms like Facebook and Instagram, us basically, as sort of workers that aren't being paid a wage. And the most, this is the whole post-operaismo kind of thing. It's thinkers like Michael Hart, Tony Negri, Christian Fuchs is one of the most famous sort of analysts of this sort of unwaged labor kind of thesis. And their whole thing is pay us. You want us to use Facebook, we're creating value for you. We're giving you data that you're using to train, in that context, advertising models, but it's also true for generative AI, right? You should be paying us to use your platforms. Another school of thought is like, this data is kind of like a resource that's being extracted. It's a bit like oil. But like, I think, I don't know, it falls a bit short because it pretends that this data kind of just exists. Like what's actually happening is that these platforms are really conditioning how we live our lives in a way that it can extract the best data from us. I don't necessarily fully agree with the free labor thesis myself because I don't see it as exploitation. If it were to be seen as like, standard capitalist exploitation, we would see this massive growth in economic sort of surplus or whatever, but we don't really. Like pretty much the entire world is kind of economically stagnating. It's more of an external. I think that the best way to view this data is something that we are doing outside this broader space of capitalist relations to kind of live our lives, Like I use Instagram because I like it. I don't use it because like I want to generate data for Facebook. It just happens to be something that we do, like a process of social reproduction where we hang out with our friends and we talk to people. And the data from that winds up getting co-opted and used as a free, cheap / free input for capitalism to thrive in the spheres of the economy where capitalism does exist. So I think when you have this expanded sort of view, it's a nice way to look at internet data. And this is also why you've been seeing all these headlines lately about like different platforms kind of, shutting off access to the data that they have, making APIs more expensive. It's because they realize that it's really valuable. Reddit and Twitter aren't going to hand out all the text that they have for free. Why would they? They can make money off it now because everyone's trying to make money off generative AI. This is also why you see things like, websites like Instagram changing their license agreements so they can get data from the stuff that you post, and they explicitly now say, we're going to use the data that you post to train generative models. They realize that this process is very valuable, but more importantly, we have realized that they've realized that the processes are valuable, and we've started to be like, hey, I don't want my data to be used to train a generative AI, which is what is forcing them to now make it explicit. Back in the day, they just do it. Like they wouldn't bother with license agreements or whatever. It's our sort of consciousness of the fact that they're doing this that has created this like new dynamic. The internet data is just one side of things, right? Like there's other data that we need to like align these models to make sure that they function well in society. There's like annotated data sets. We've had like a few talks talking about like exactly what these data sets look like, so I won't go into that. A lot of this stuff is annotated on platforms like Amazon's Mechanical Turk, right? Like a lot of it is kind of, we've got like these gig workers that are working in super precarious conditions. They just kind of have to be on their screens. We don't pay into their pensions. We don't pay into like any sort of like, they have no kind of job security because we're not a job. They own the laptop. They're just using the platform. The traditional sort of relationship between the employer and the employee that was won in a lot of the world after the war is kind of being eroded by platforms. You no longer have this sort of sense of security in your relationship with your employer. A lot of this also happens in the global south, right? Like a lot of data annotation happens particularly in Turkey, in India, in the Philippines, places without the right kind of state mechanisms that can be like, hey, maybe you should be paying your employees a living wage. And this also ties a bit into imperialism, where over the last couple of decades, the IMF have kind of forced sort of structural reform into a lot of countries, which have created these conditions, right? Like it's important to not view them as something that just happens because these are poor countries. These conditions have been sort of explicitly created, and you see it now. You see it with Egypt, you see it with Sri Lanka, this kind of process of forcing these countries into, eliminating whatever state capacity they had to regulate markets. So this is exploitation, but it follows a very standard kind of colonial pattern. And there's people that have analyzed this as the whole school of data colonialism. There's people like Jim Thatcher, and I should have put in citations, but I didn't. Oops. And this is also political, right? It's quite directly the sort of political interference in institutions that exist in other places. So this is also kind of a case for it's a bit blurred, the lines between economic and political, even in this context. And there's obviously lots of articles about it. And some of these stories are really quite, terrible, to be honest. There's reports of data being annotated, refugees and refugee camps being made to annotate data. There's reports of Kenyan moderators going through massive mental health crises because they have to annotate racism and violence towards them as So you'll find millions of these stories, to be honest, just Google it. People love to report on this these days. It's all over the news, the most sort of egregious kind of examples of how this happens. Okay, not everything is about data, there's also code. And this is the sexy part of generative AI, you know what I mean? It's someone's designed the code for ChatGPT, someone's written these cool models that work. You have the attention paper, then you've got that being turned into transformers, so on, so on. what I want to focus on here, there's a lot of different venues where this happens, but for the purposes of this talk, because I'm in a room full of academics, I want to talk about how academia is one of these sites. And what happens here, the relationship here has been one of transformation of academia since the 70s. You know, there's people like Sheila Slaughter talking about it. There's people like Nick Dyer-Whitford. But academia in a lot of places has turned into this site, is being turned into the site where you are generating intellectual property for corporations to then co-opt. This works extremely well for the corporations because they don't have to pay you competitive wages. They can make you do work for them on state wages. And because of open science, we make our research papers open source. And it works out very well for Microsoft and Google because they can then use that research. Nation states also like this because they've used it as part of their whole national competitiveness strategy, you know, like generate intellectual property for us in our universities. We need the finest minds here working on the finest things that we can then turn into ways to commodify more things. And like, what's like sort of quite interesting here is that this is also kind of a process of expropriation, right? Like academics don't strictly function in a proper labor market. We're not paid competitive wages, we're paid state wages. This is a good thing. I'm not saying that we should be paid competitive wages, to be clear. But this is kind of how companies obtain our research as free inputs for what they do. And this is also accompanied, the way academics are made to do this stuff is through increased precarization, right? Like over the years, I can't think of a single year since I entered academia that there has been funding increases, you know, like, oh, look, here's a lot of money, do whatever you want. Like stories globally are consistently about how funding in different academic sectors are being slashed, how academia is expected to be like competitive in the market. The Netherlands, I believe, has like this whole thing where you're supposed to like now get like a private sector, like get a company on board with your research projects to get state funding, like a literal sort of intersection with market mechanisms. And there's, yeah, like we all know this sort of thing, like how precarity is kind of used to discipline academics and extract very specific kinds of research from them. And this is sort of the point that I want to make, right? Like artificial intelligence is a good thing because it technically means automation, but the path that research follows is not conditioned by our sort of actions as rational actors. It's conditioned by the market. You know, it's conditioned by mechanisms that are used to sort of elicit a very specific kind of research focus from us. Deployment is another really interesting case, right? And I want to talk, there's a lot of like, this is McKinsey, it's like a bullshit consultancy firm that like, it's really nice to read their reports sometimes to see what the hype people think about like how this is going to work. And they're really optimistic about like generative AI being used in sales and marketing. There's a lot of other spheres as well, but I really want to think about this for a second, right? It's really, because it's really fascinating when they talk about like artificial intelligence and productivity and then talk about marketing. Because advertising and marketing is not a productive sphere of the economy. This is not a moral judgment, you know, like advertising and marketing is fine, but what it basically does is it shuffles people's spending money from one capitalist to another. Like, I don't want to buy Adidas trainers because Nike had a better advert, so I'm going to buy like someone else's shoes. You know, that's kind of how it functions. It is, when you automate things in a car factory, in an automobile factory, which is like the classic Marxist example, what it means is that you're able to produce cars with less human labor and much cheaper, which is good for, you know, broader society. When you automate things like advertising and marketing, what exactly is being produced more cheaply? Like, all that you're doing is laying off a bunch of people, and everything costs exactly the same. Like, good job, I guess. Like, you've brought us slightly closer to crisis. This has solved absolutely nobody's problems. There is other spheres, I won't deny that, where like, you know, generative AI might lead to some improvements in productivity, such as like, you know, things like GitHub's Copilot. But I won't talk about that now. Right. We can't talk about this just in isolation, right? Because like all of this really deeply ties down to actual material things. Even the products that are being advertised and marketed, let's be realistic, most of them are things that are made in like these massive factory complexes in China. So there is deeply, at the heart of all of this immaterial sort of abstract artificial intelligence, there is the real world. You know, there's actual physical things like GPUs. And I've done this like really shitty sketch in like Keynote that's like trying to illustrate the sort of flow of money in like a very hypothetical generative AI scenario. How do I? Nice. So up there you've got us, like the users of these systems, right? And the arrows are where money's flowing. So we pay OpenAI for like ChatGPT. Governments pay OpenAI because they want like, all of you remember Sam Altman's whole thing, right? Like the guy was like doing tours in the United States and Europe, in Abu Dhabi, in Dubai, just trying to get like money. Just pay me, you know, pay me 600. I think he was trying to get $6 trillion from the Emirates. It was insane. I don't know if they gave it to him, but like, yeah, it was quite nuts. So this is the whole thing, right? Like, give us money, give us money. Venture capitalists also really get like super pumped about this, so they pump a lot of money into generative AI. It's important to remember that venture capitalists, their money didn't come from nowhere. Like after 2008, like Western governments printed insane amounts of money through quantitative easing and basically gave these guys money, saying invest in whatever you want to. The interest rates are 0. You can take on as much risk as you want. And they were like, cool, I'm going to invest in Bitcoin. Microsoft now own OpenAI, so this is a very specific example, obviously. Microsoft own OpenAI. They own products like Azure, Office 365, Windows. That's their main source of like revenue. That's how Microsoft make their money. NVIDIA manufacture the GPUs on which most of these systems are trained. So they're very, very critical in this whole chain, right? Like without NVIDIA GPUs, you can't do anything. NVIDIA don't manufacture their own GPUs. They only possess the intellectual property for them. The GPUs are manufactured in Taiwan by TSMC, which has been described as a sweatshop. There was this whole thing where they tried to open a subsidiary in the US, and the American employees said this place is a sweatshop, and the Taiwanese employees said Americans are lazy. They'll never be able to do it. Insane. And at the bottom of this whole chain, there's people working in mines, obviously, which is where like a lot of the sort of the minerals to build these GPUs comes from. I want to focus on the areas that I've highlighted in red and green, because I think this is where the sort of techno-feudalism thesis kind of becomes interesting, right? Microsoft are paying a shit ton of money to NVIDIA, like an insane amount of money. I think you've all seen NVIDIA's like stock valuation in the past year and how it's just gone like whoop. NVIDIA don't actually need to do anything. They could just chill out and like hang out with the intellectual property for GPUs that they've owned. You know, like they basically have a monopoly position with CUDA, which is a toolkit that a lot of AI models are coded in. NVIDIA kind of dominate the entire market. I don't think anyone is writing things for other GPUs at this point. It's all NVIDIA. So Microsoft are paying an immense amount of money to NVIDIA. Is this rent? Like, are they paying NVIDIA money because they cannot have competitive prices? Are they just paying them huge amounts of surplus that they get from like venture capitalists and from us as like a rent kind of thing? Simultaneously, Microsoft charging rent for Windows, because Windows is also intellectual property. You know, like we could recreate that operating system if it was open source. So like, at what point does profit become rent? You know, and there's also these green lines, which is like platform rent. You know, so like with Azure, for instance, which is Microsoft's GPU rental service, they invest in fixed capital, they buy all these GPUs, and then they get money from us constantly, forever, for eternity, for access to the GPUs. They can make like insane profits on this, you know, because you only have to buy the GPU once. You can charge like access to it. Like it's like owning a house, but you can only rent a house to one person. You can rent a GPU to like loads of people. You know, it's quite like an interesting sort of thing that's worth analyzing. So I think that like the whole conversation between the techno-feudalism school is kind of interesting and needs more analysis, I think. So basically what's happening is that our greater sort of societal surplus is being spent by governments, it's being spent by venture capitalists to kind of prop up generative AI. You know, they've been trying to raise money. A bunch of companies get mega rich. They're not even necessarily the generative AI companies. They're companies like NVIDIA, which was the biggest winners in this entire thing. It's not even really profitable, right? Like, and I can't stress how important this is. OpenAI does not make a profit. OpenAI is like massively, like their losses are insane. The only reason they sustain themselves is because of venture capital. Like this entire sphere, the costs of running it are so high that like without just like scamming people into believing in the future, they can't really make money. And ultimately, it's also just like sort of environmentally devastating, which you're all familiar with. Like the more and more reports about like, you know, sites in Ghana being used as waste dumps for AI, sort of like the kind of GPU emissions. Yeah, we all know about this. Why are we doing any of this? Like, how did this happen? How do we end up here? You know, we could have ended up with like not having to work ever again for a day of our lives because AI would do it for us. What's going on here? It's all about ideology, and there's a lot of ideology in this space because people love that shit. So there's like two schools that I want to talk about, right? Like there's these guys, the accelerationists, you know, it's like people that talk about how this is the future, just like develop, let's just go, let's get rid of all regulations, like drive artificial intelligence to its logical conclusion where nobody has to work ever again. Accelerationism has a great history, actually. It's not like as new as people think it is. It kind of originated in like the late 90s at this place called the Cybernetics Culture Research Unit in Warwick, where like a bunch of academics would do a lot of drugs and talk about like how they could like bring capitalism to its logical conclusion. I'm not joking. One of them did so many drugs, he went kind of insane and turned into like a very now pretty well-known race theory philosopher. It's quite crazy how this happens, yeah. And there was like, there was these two strands of like left accelerationism and right accelerationism, where the right accelerationism was like, let's just go, I don't give a shit, like let's burn the planet down and build technology, and we can finally have like, we collapse everything. And left acceleration was like, yeah, maybe we should also think about people. And EAC is like the modern effective accelerationism kind of current that's like adopted from both of these people. But they basically, what they want to do is they want the state to get rid of regulation so they can do whatever they want. And the other school are these guys, who talk about like how artificial intelligence is going to go back into the future and torture us endlessly for failing to bring it into existence. How like artificial intelligence is going to hunt every single person down and kill us because we didn't like declare our fealty to it in advance. People like Elon Musk, to nobody's surprise, are like big on this whole thing. They keep talking about regulating them. They're like, please, state, regulate us, tell us what to do, like stop this from going out of control, which kind of makes some people think they're the good guys. But what they're actually saying is, give us money. We're the only people who can fix this. Give us money. Give the other guys money as well, but also give us money. It's all about getting money. It's all about like trying to find a grift that lets people redirect money to them. And they're very good at it. Like both these schools are very good at it. Like look how many governments they get invited to. Look how many talks they do. So to conclude, what is the takeaway from all of this, right? Like I believe that all of this is because there is a huge crisis of profitability in capitalism. And writers like Aaron Benanav have been really good on this in the past like 5 years. They've traced out how capital continues to fail to make profits and has failed to make profits since like the sort of industrial downturn in the 70s. There was a brief moment where like Chinese productive capacities like led to a lot of like growth, like the Chinese experiment has been one of the greatest success stories of our time. But like beyond that, like it's just constant like stagnation. And he argues that also Chinese growth was at the expense of Latin American stagnation, but like I won't go into that. This has kind of led capital to just sort of flood things, like flood very random sort of spheres of the economy. One of them, the famous ones have been like NFTs, like where people pay insane amounts of money for these like chimpanzees or like apes, like I don't know what they were, like some animal. Artificial intelligence does things. It's less like obviously fake than like NFTs. NFTs were like clearly bullshit. Like I'm sorry, but like who bought into that stuff? Artificial intelligence at least does something. You can use ChatGPT. You can see it say things to you. So it's like it kind of sustains itself, but it's just at what cost, right? Like it sustains itself only because you have this whole sort of undercurrent of precarious labor, kind of propping up this entire space, like keeping up this sort of facade of generative AI being this autonomous thing. It still isn't profitable. Despite this insane, like these insane labor violations, it still can't make money. It's quite absurd. All it can do is redirect money from like venture capitalists and like hype-driven governments. It still can't make a profit, despite like being so exploitative. And of course, like when all of the hype collapses, because inevitably it will collapse, right? The damage is kind of done. We've got like the environment has been set back considerably. We've also like completely enshittified the internet, which is a great word that Cory Doctorow uses. And he talks about how, like, now we just have like sort of spam bots flooding everything. We have like sort of extremely horrible things, like deep fakes kind of becoming a thing on the internet. Literally just yesterday, Hugging Face, the like saviors of the open source world of generative AI, hosted a model that would generate deep fakes of like a particular individual influencer. Like this was absolutely insane that this is happening. So we've kind of like, I don't know, if you talk to the average person, they find this stuff really creepy. Yeah, like people use things to like send emails and stuff. Like they like ChatGPT for like, I use it sometimes, like I'm sending like a mail to the German government. I'm not going to do that myself. Like, please, ChatGPT, do that for me. But like beyond these like minor use cases, which like honestly are jobs that I shouldn't have to write a letter to the German government anyway. But like apart from these things, people find this very creepy and very weird, and that kind of ties into what Emily was saying, right? Like, a broader society is just sort of like, I don't really want this, man, like, cringe. People find it cringe. Yeah, that is the right word for this. So the question that we need to ask ourselves as people, I propose that the question that we need to ask ourselves is how we liberate artificial intelligence and automation research more broadly, because automation is a good thing, right? Like, the less work we have to do, the better. Like, how do we liberate this from the markets, which are driven by just obscene sort of irrationality? And, that's the talk. Thanks. I didn't realize that would happen if I...
Do we have any questions? We have a couple of questions, and I lost the microphone.
It's over there on the table.
Oh, then use it, please.
It's on.
Very nice. Thank you for this fantastic talk. I want to have one question and one comment, but I'm not sure which is which. So one thing is, let's go with this one first. I object to the claim that we own the means of our own production, namely the laptops. It is true that we own the hardware, but this hardware is useless without the software that is running there totally on a rent basis. Like it used to be the case, I pay good money for my bloody phone and I own it, but now basically 3 updates later, it's useless to me. Right? It cannot update anymore because the hardware is too old, and it cannot run the old apps because they are not, they get disconnected from the thing. And the second thing is the issue with discussing this. I mean, I absolutely agree with you. The problem with keeping this aspect of AI and AI alignment into focus is that whenever you say capitalism, the people flip into this Cold War mode and think the opposite is communism. And I mean, communism is even worse. So therefore, capitalism, right? So we have to put this conversation in context with what are the options, because the option is not to the option to capitalism is not communism. The option is better society, right? And in this specific context, markets have this. The reason why we like markets is because they have this very high democratic aspect to them. We are all the market. So if I don't want something, then I will vote by not buying it. The thing here is that there is a lot of manipulation going on in razzle-dazzle, dragging your attention. Look at this shiny technology that we're all going to make money out of, but the people who are peddling to us don't make money out of it. I guess there were both comments, but I would like to hear your thoughts on it.
To the first one, I wasn't saying that I believe that we own our own means of production. I don't. People believe that. I completely agree with you. So like, that wasn't an endorsement of like we own our own means of production. To the second point, yeah, I'm aware that there's like Cold War rhetoric, whatever. Like, I'm also like, to be honest, like the way you present this to a room full of like academics that are interested in thinking about this is different from the way that you should be presenting it to like broader society, right? Like, I'm not very good at that. So like, I let other people like translate this into like sort of a safer way to kind of express what these concerns are. For me, it's more about like actually highlighting the concerns. And I agree with what you're saying. How we sort of frame this is very important, especially in Europe, because people have this, like you said, this like, oh no, the Soviet Union is back, kind of thing. China, which is extraordinarily capitalist, actually. So like, it's quite funny. With regards to the democratic potential of markets, there's like this. So Nancy Fraser talks about this like really well, right? Like there's like this dual purpose of markets. The first is as a place of buying and selling, and I can exercise my sort of democratic vote by refusing to buy something, like you said. The second thing is markets also act as a center to coordinate economic activity. Like, how is society's broader surplus invested? And what spheres of the economy should we invest, like, the fruits of everyone's collective labor? And that is a much less democratic process, because with that, the more money you have, the more ability you have to design what gets made, right? Like, my withdrawing from ChatGPT is not going to solve anything if Elon Musk pumps like a few $1 billion into it. So there's like a democratic side to markets and a liberatory sort of aspect to markets, combined with this other kind of markets as a means to make money versus markets as a means to decide what is produced. Which, yeah.
Thank you. We have one more question.
So thank you, Vinit. Super, super interesting. By the way, the last thing you said, so you believe in both these two things, right? These two versions of market, democratic market, and
I believe that there's like two different purposes for a market. Yeah, that's not my thoughts. Like, I'm just like paraphrasing someone else.
Okay. I mean, I like to believe. I mean, I might be wrong, but I like to believe that we can have some power and that we can exert on this power through our choices. There was a term that was quite fashionable some time ago, like prosumer. Like, we are producer and consumer at the same time. It sounds nice, but anyway. No, my question is, so I'm a big fan of automation and like making people working less, right? I mean, everybody knows that, right? I mean, everybody like that, right? And the point is, I mean, maybe the more people want this is connected to the democratic market Marija mentioned. The more we make this argument that AI can automate everything, maybe we can really push the market in that direction. What do you think about that? So, I mean, to say in another way, do you believe that we can indeed reach this, if not full automation, semi-full automation? What do you think about that?
So there's a great book that I would highly recommend that you read because I think you would really enjoy it. It's called, I mean, the title is slightly self-explanatory. It's called Automation and the Future of Work by Aaron Benanav, who's like a very creative, like sort of contemporary sort of political economist. I really enjoy his stuff. The point that he tries to make is that because of this collapse in the rate of profit, like you can't really productively invest capital anymore because you don't make any money on it, which is kind of what has tended to this like sort of capital moving into scams. So his argument, which I kind of agree with, maybe depending on my mood, like I don't have the answers, right? Like, but he argues for like a return to massive Keynesian sort of investment, right? Like the post-war sort of state, where we kind of like, I do believe that there are things that we can do, like as individuals. We're even better when we're with other individuals, which is why I advocate for unionization. That works out really well very often. But like, yeah, there are things that we can do in these contexts, and I guess like, we need capital to not think about profit. Like it's the profit drive that leads to this sort of weird extractive sort of stuff happening. Yeah.
Any more questions? No? Then we thank Vinit again. Thank you, Vinit. The next speaker is finally here. Nadine, the floor is yours.
Hello, everybody. My name is Nadine Kokciyan. I'm a lecturer in artificial intelligence in the School of Informatics, University of Edinburgh. I just came this morning. I can be a bit like sleepy, but we'll be fine. Don't worry about it. Today's talk is about like enabling responsible AI with humans, and it will be a high-level talk. If you are like interested in the details, you can always like check the papers. So I will not go in depth, but I just like give you like a broad understanding of this area. Probably one thing to mention is as well is like I'm also like a senior research affiliate with the Center of like Technomoral Futures, which is a part of the Edinburgh Future Institute at the University of Edinburgh. They are doing some cool stuff. If you want to check, just before I start, I just like want to like provide like some quick introduction about myself. As an academic, of course, like there are like many things that I do, like big. Of course, I want to spend all my time in research sometimes, but it's not the way it works. But I have a research lab, which is called Human-Centered AI Lab, Child Lab, and we are like doing like some research in AI, where the focus is on human-centered AI. It's more like how we can come up like with practical applications of AI that can help humans to make like informed decisions. So I have like, I mean, as a lab, like we are doing like some work in like in the privacy context, for example, how you can like help people like to make privacy decisions, how you can detect privacy violations, or like how you can prevent them in the first place, these kind of topics. And there are also like some projects that we are working on about like responsible AI and AI ethics. And today I'm gonna just talk one of the projects in that context. And I'm also a big fan of argument mining. I do like some computational argumentation research. In this area, the idea is more like we have like this unstructured text that is everywhere, so it can be something like users like sharing like some data on social media, or it can be like the news articles that you are reading, any content. But the idea is like how you can like start from something written in natural language, and you can translate it into something computational. So this is like the field that argument mining is looking at. The idea is like start with this text, try to identify the different arguments that people are making, and also try to identify the relations among those, because like some arguments will be attacking some others, or some of them will be like supporting each other, and then try to understand what's going on when people are talking to each other, for example. But today's research, today's topic will be more on the responsible AI and AI ethics bit, and I will also talk about the privacy bit. And when it comes to teaching, I'm teaching some AI courses in the school. The first one is like introduction to AI kind of course, reasoning and agents. I'm a big fan of logic as well, and I do use it like in my research. And I also like developed a new course, case studies in AI ethics. If you are interested in the materials, everything is online. You can just go to our website and see, and you can also get in touch with me in case you are wondering what we are teaching. So I want to talk about Edinburgh Declaration on Responsibility for Responsible AI. So this is like a joint work with so many researchers in the UK. I don't know like how familiar you are with the UK, probably not, but we have like a institution called UK AI Transport Autonomous Hub. And these people, this research entity is like funding so many research projects. And one of the nodes that they have like very different things. For example, they have like a bunch of projects looking at trust, bunch of projects looking at verification, or bunch of projects looking at like security. And one of the topics is responsibility. And a year ago, we organized, I was not part of the organization team, but like in Edinburgh, a symposium happened, which was like this transport autonomous symposium, I guess. It was the first one. And all the responsibility node projects like came together, like all the people working for this project. And more than like 20 people just like worked on this declaration, because everybody was like, look, I mean, we are using this term, we are not talking about the same thing. It was a bit like more trying to understand, could we come up with like a things like, I don't know, like steps to identify better what we mean by responsible AI. Because if you want to implement something without giving that like a definition, it's just so difficult to implement that. So this is why we sat down and like we worked on this. It's online, you can access it, and you can have a look if you like it. That's great, I think it's good. But I hope I'm gonna convince you to go and like check for more details. But there are like, if you go and check, you will see that like there are like 4 main topics that we are discussing in that declaration. If you want to achieve a responsible AI in an autonomous systems, we are talking about 4 different steps. And the first step is the accepting responsibility, that I'm gonna like provide some examples. Because the thing is like, if you want to be a responsible organization in the first place, you should be wanting that, right? So it will not happen like in a day. So you should be really like making like the steps as an organization to make that happen. Acceptability is the first step. Second step is like focusing on the relations. Most of the times, I think today in many of the talks, we talked about humans a lot. And it is something that I also like want to emphasize in this talk and about its importance. Third one being, if you want to like as an organization provide like some AI technology to people, as an organization, you should attend to vulnerability of people. You should like listen to them when ethically significant harm happens and try to like find a solution to make them feel better about their situation. And the fourth one is, I know that we are not like talking about this a lot, but we should not forget about like the sustainability aspect of responsible AI systems that we are developing. I mean, today in a bunch of talks, like people like were talking about LLMs, etc. But also like we should not forget about like the impact that it makes like on climate change kind of things. So let's like look at like each of these topics a bit more in detail. Let's start with the first one, so which was like about accepting responsibility. Today again, like in many talks, everybody was like talking about context. For example, Nardine was like talking about like values, and like of course, she was also like telling us like you should like be considering like values within their context, and context is key. And if as an organization you want to be responsible, there are like so many responsibility definitions out there. So it's like, I think as an organization, one thing to do is like, first of all, when you say responsible AI, which is like the particular definition that you are referring to. For example, are you talking about moral responsibility, which is something like when something happens, who is accountable or who is responsible? So this is like then we are talking about moral responsibility. Or legal responsibility, like who is the liable entity, like when something happens? Or causal, like which particular event triggered the other one, therefore something terrible happened, right? So like this is like about causal responsibility. Then we have role responsibility, like when something happens, who is like the person that you should talk to? Or a bunch of people, I don't know, but it is something that you should discuss. Or virtue responsibility, which is like more about when something happens, is the person that you are talking to, or like is the organization that you are in touch trustworthy enough, right? Then we are talking about virtues. But again, so it's about definitions. We should like talk about these definitions because we cannot mix things together. If it is the case, we should like make it explicit a bit. And as I mentioned earlier, responsibility should be accepted, especially like with the people who are in the power. I mean, for example, if you are a money, cash person, this will not work, right? So it's like, first of all, you should be really like, put your resources in if you want to be a responsible organization. And yeah, people in the power are the people who should be implementing this in the first place too, because like without them doing anything, nothing will change. I mean, as researchers, as academics, or many students are also like working in the field, I mean, we can come up like maybe best solution ever, but if it's not implemented or if it's not like practical, it will not work. Second aspect is relational. So many times, I mean, I'm sure that like you heard about this a lot. Every time that we are talking about responsibility, we are treating responsibility as if this is like a property of an agent. When I say agent, it can be like an automated tool. It can be, yeah, something like something intelligent too. But the thing is, like, responsibility is not like a property that you could assign to one entity. When we are talking about responsibility, we should also like consider like the relationships that are affected by this. For example, if I am using a product from a company, let's say, and something horrible happens to me, the thing is like it's damaging my relationship with that company, right? Probably I'm gonna go to my friend, I'm gonna say this company did this to me, and like because like I have like this relationship ongoing and it's damaged. But here the idea is like more as an organization, when you do something wrong, acknowledging the problem, and also like try to repair that relationship with the people. So because if you don't make it work, it means that like people, you will not be able to like increase the social trust of people using your platform. But if you do something wrong, it's a nice thing like to try to repair that relationship. I mean, think about like people, right? So it's like sometimes you have friends, maybe they're like very good friends, they do something, and trust is something that is very easy to lose. But the thing is, like, over time, you are trying to repair that relationship. And the moment that it goes well, probably your opinion will also change. But you should, like, see, like, an attempt from, like, the other party when something goes wrong. At least, of course, it should start with an acknowledgement from the other place, as we were seeing in the previous one. So this is why, as a second concept, we just want to focus on responsibility as relational, like, focusing on these, like, human aspects of, like, the importance of, like, sustaining relationships. And we believe that like we should like move this to the core of like the systems that we are building. Third one is about attending to vulnerability. Most of the times when problems occur, what we do is like we want to find that responsible person. We want to like assign that blame to somebody, and then we'll be like, okay, my problem is solved. It's not like that. Of course, like we want to like punish, like let's say, the responsible parties. But at the end of the day, I mean, what we really want is like, we want that person maybe come to us and apologize, you know, like, or maybe making us like some promise that something like that will not happen again. And this is why we are also saying that like when organizations are willing to be responsible, they should also like be attending responsibly to the vulnerabilities of people. Again, this item is also like so human, so it's not like anything technical that you can solve. And the fourth one is like sustainability. Of course, like this is like a very difficult topic because like again, there are like power dynamics here. Because economic growth, rapidness is like in one hand, and on the other hand, of course, there is a safety, security, and control measures. But the thing is like everybody wants to be the first. Everybody is like want to be like very quick, produce something, be the best. But I mean, without like spending so much time on it, it's so difficult like to come up with something secure. I mean, the landscape that we have at the moment is like these big tech companies, like OpenAI, for example, they come up with a model. It's not open source. They just release it, and they just wait what will happen, right? So it's like everything is just evolving so quick, and people don't have like time to sit down and like do something proper. But it's again the power dynamics, and it's more like a social science. It's a human problem again, actually. And yeah, there are like, unfortunately, from a sustainability perspective, there are like great demands on like our limited resources, and there are like growing challenges, etc. But like this is something that we should not like forget when we are focusing on technology. But these are like the vaguely like the 4 steps that we are like discussing in the declaration. And in today's talk, I'm gonna focus like in the first 2 items by talking about like 2 specific projects like that are like relating to these 2 items. The first one is an example project which is focusing on this accepted responsibility bit. As I mentioned earlier, responsibility can have like many definitions. in this particular project, we are focusing on moral responsibility. To remember, moral responsibility is about when something happens, who is accountable and who is answerable. So this is like the concept that we are trying to find an answer for. Before I jump to that, I want to talk about socio-technical system. Did anybody hear about this term? Yes. Can I get a quick definition?
It's like social, yeah, and technical.
Really? You will say the same? Please don't.
Depending on whose version you're talking about, it's normally like the different layers that go on within sort of governance all the way through to it's social and technical in a system.
Yeah. I mean, the thing is, like, most of the times when we are talking about, like, something went wrong, etc., or AI did that mistake again, people are always referring, like, to like, technical aspect of things. How I can, like, fix my data set, which is not balanced, how I can come up with a better algorithm, how I can make it, like, more efficient, blah, blah, blah. All of these are, like, technicals. So when we say socio-technical, actually, it's also like incorporating like the inputs from the people. Because when you say humans, I mean, we are talking about people who are using AI systems making decisions. We are talking about people who are exposed to the outputs of AI systems. We are talking about regulators. We are talking about policymakers. We are talking about so many people, right? So it's like we should not forget about like the technical systems surrounded by like these different types of people, where we are getting the data, who are feeding the data to the system, and who are part of this system, actually. So this is why we should like remember the socio bit when we are talking about socio-technical systems. But it's very complex. I mean, as you can see, yeah, nice. So it's about people, as I mentioned. So like there are like so many people interacting with this system in very different ways. Of course, we are very aware of the technology. We are only focusing here, unfortunately, but as you can see, we have so many other components. Cultural, every person is from another background. Of course, there will be like some cultural differences when they interact with the system. People, organizations have like some goals to achieve in socio-technical system. Of course, we are talking about like processes that are like connected to technology as well, and infrastructure. And all of these things together, it's so difficult. I mean, imagine like when something goes wrong in such a system, it's almost like impossible to debug. And it is like where the problems start, right? So many challenges, many stakeholders, so many people. When something goes wrong, sometimes you're not able to check. When we are talking about socio-technical system, you are not talking about like one specific system in place, because it's an organization where when you are deploying an AI technology, it probably means like you are like deploying like a chain of AI technologies, because I don't know like how many people did any coding here. Is like the moment that you start coding is like import that library, this library, do that, do this. Like you are like chaining a whole AI technologies into your solution. And when something goes wrong, who knows like where the problem is coming from. Bias is inevitable, as I mentioned. So it can come maybe from the data set, it can be from the model, it can be from the human like who are like using the system. It can be anywhere. Explainability becomes a challenge. I'm sure that like you heard about like this black box terminology. Nowadays, I mean, we are providing some inputs to systems. We get like some outputs. We can observe the outputs, but we are not able to observe what's going on within that box sometimes, and which makes our life so difficult. I mean, imagine like the LLMs. I mean, when you are like talking to ChatGPT, we don't know what's going on there. Yeah, you are interacting, maybe saying something like reasonable, that is like looking like human-like answers, etc. But at the end of the day, when you say why, we don't know why. For some reason, it learned, not learned, I mean, it just mimics like some data that it saw somewhere else. And of course, like from a auditing point of view, everything becomes very difficult, because if you are talking about like the interaction of opaque systems, and then almost like the auditability becomes like a big problem. And yeah, now I want to talk about the responsibility gap. Does anyone hear about this term before? Usual suspects. You will say responsibility gap, right? Yeah, what is responsibility gap?
What's the cause of the gap?
What is it? What is responsibility gap?
When you don't know whose job it is to take on the responsibility, or hard to figure it out, right?
Yeah, exactly. When, for example, Uber was like testing like the driver, like the autonomous vehicles, like for the first time when an accident happened. Of course, the first thing like,
I don't know, right? So it's like, yeah, of course. Of course, they blamed a human in that specific case. But most of the times what happens is that there is like this very nice explanation that people are using in general. I didn't do it, AI did it. But who deployed the AI? It's you, right? So it's like, there's like this responsibility gap problem that we have. I mean, we should acknowledge that this will not go away. So it's something scary. It will happen, but like the idea is like more, what are the solutions that you can come up with in order to like reduce the size of the responsibility gap and not increase it? So probably it's the best that we can do. And this is why we started this project 2 years ago. The name of it's now, I think, it ended by the end of October. So, and the name of the project is Making Systems Answer, Dialogical Design as a Bridge for Responsibility Gaps in Autonomous Systems. This is a multidisciplinary project funded by UiB AI. And in this multidisciplinary project, Professor Shannon Miller was like the principal investigator of the project. She's a philosopher in ethics of AI. And there were also like some other people from different backgrounds. For example, there was like the informatics team who was looking at like providing the technological framework, whereas we also had like some other people from like Usher Institute, which was like more coming from a bioethics background. And then we sat down like all together, and we are thinking about like this project. The first one being, of course, in philosophy, that we have like so many theories out there. So sometimes it's just a matter of like finding like what is suitable to today's world and how you can take that theory and try to apply to today's world and try to solve the problems that you see. And answerability is such a thing that Shannon Miller and Tilman Birkant, in our philosophers in the project, sat down and like they were trying to identify how this theory could be applied to like socio-technical systems. And then the second bit of the project was like looking at the moral theories of responsibility and like going like to stakeholders and try to understand what are the user needs and try to understand like the human expectations. And as you can guess, the final bit was like about, can we come up like with a solution at this with a prototype that could solve this responsibility gap problem. And our solution that I'm gonna focus later on is like more about, we have these organizations who want to be responsible. We have like these people, when something happens, they need some answers and they just want to talk to someone and get some answers. But at the moment, we are not able to do this. I mean, sometimes the best that you can do is like, you just like give a call to a customer support, maybe like tell your story hundreds of times. If you are lucky, maybe you will get a response, it will be resolved. Most of the times, you will never like talk to somebody who is really responsible regarding what happened. And our idea was like, could we come up with something in the middle, like a platform that we call a mediator agent framework, which like facilitates the dialogue between organizations and people and try to solve this dispute, let's say, when something happens. When I say answerability, probably it's also like a good idea to like stop for a moment and like think about what is answerability. Because every time people, when you say a system should be answerable, the first thing that people are thinking about is only explainability. And answerability is more than that. Answerability is more like an umbrella term that includes many things. Of course, explanation is part of this. I mean, if, for example, I say, I don't know, they say, we stopped your treatment. As a patient, for example, you can be like, why, right? You can just ask for an explanation. So it's part of it. Sometimes it's just justifications, right? So you just say, you know, these things happen, therefore this consequence is what you face, kind of thing. It can be apologies. I mean, people are really different. So this is why I am emphasizing the needs of users, because they are just so different. For example, somebody could be like, just give me an apology, I don't care. Just apologize to me, right? So that because something horrific happened to me, just apologize, acknowledge the problem. And sometimes it's a promise. Some people are like, promise me that this similar thing will not happen to somebody else, right? So this is, all of these are like very human, and we don't have any of this actually. Or sometimes it's compensation. Of course, like so many, if whatever happened to you is not like very, very serious, if it's like a low-stake problem, in general, you will be like, okay, give me like a 10-pound voucher or something, I'm gonna be fine. You know, like, it's the quickest, but like sometimes horrific things also happen. A compensation, monetary compensation will not be enough. So here below that you are seeing like a one of our workshop papers, but which is like it just like gives like a general idea about the project. But yeah, for more details you can refer to the paper. And this is like what we develop at the end of the day. You are seeing this mediator agent technology that I was talking earlier. Here we have a chatbot which has like a robust implementation behind. We also published a demo paper about this in IIIA this year. I mean, if you want to download the code, play with it, not this paper, but like if you can go to the ALMAS this year, it should be like in the proceedings now. And yeah, here the basic idea is that we have like this chatbot which is like facilitating the dialogue with the user. Of course, like there is this elicitation process where the agent is like trying to understand what happened to the user first. But since the chatbot is also like knows like so much things about like the organization itself, it's able to mediate the conversation to the right people. And some of the cases are very easy. If like it's a low-stake thing, the chatbot is capable of like handling the problem itself. But if it is something more sophisticated, it will always connect the user to the human representative. And such a thing like the focus of this is just always responsibility. And we are also like providing like some documentation like for practitioners, like how to deploy this, how to like adapt that into their organization and these kind of things. But for more details, you can like just refer to this paper or the demo paper that I was mentioning earlier. And second bit, so we talked about like the acceptability, and I said that like the project was like more about the moral responsibility. And now I want to like give an example about what if we want to see responsibility as something relational. So if we want to remember what it was, is like we are focusing on the relationship that the person has with the platform that they are interacting with, and we want to like sustain this relationship with the platform. And this is like coming from my privacy research. It's a published paper 2 years ago in IIIA. The name is Taking Situation-Based Privacy Decisions, Privacy Assistance Working with Humans. Here the idea is that coming up with an AI technology that could collaborate with people in order to make privacy decisions. So it's like the basic idea. So I'm a big fan of like having this hybrid AI, human AI systems to solve important problems. So here, as a value, of course, like we are focusing on privacy. And this particular paper is about IoT. I'm sure that like all of you have like tons of like IoT devices, maybe, I don't know, like, but it's right now it's like very accessible. I mean, everybody has like a smartwatch, like smartphone, I don't know, smart thermostat. I mean, everything is becoming smart, let's say, but it means that like they can also like collect data about you, the environment that you are living in, and all the contextual information. But the thing is like IoT is like large. It's very dynamic. You can like add or remove like devices very easily. It's very heterogeneous because I mean you can go for a very expensive brand versus you can go to a very cheap one where the quality of the data that you are dealing with will change drastically. And these devices, of course, like are capable of like collecting the data, store, process, these kind of things in the cloud that we call like edge computing kind of thing. And you cannot, of course, we cannot imagine a world where the user will be like sitting with their phone and where they will be allowing or like allowing like all the data that is being collected. Probably it will be very depressing if it was the case. But I mean, this is not working. I mean, even like people hate like interacting with the cookies when they're like trying to like interact with websites. I mean, imagine that happens every second with your phone. Here, the basic idea is like, let's automate this. Let's have like an agent-based privacy assistant that knows the user very well, that can like represent the user preferences of the user when it comes to privacy. And then the idea is like, let them make decisions together in different situations, in different contexts. So here you see an example privacy situation. This is coming from a real-world data set, actually. Here I just want to focus on like different aspects of this scenario, because when you say context is so vague, I mean, whatever I mean by context will be so different from what you mean. For example, it can be the location. It can be like the sensor that is collecting data about you. It can be the nature of the data that the device is collecting. It can be the purpose of the device being like deployed. It can be like the purpose that organizations want to fulfill. Or it can also be about the retention policy, right? So all of these things together can like be a representation of a context. But by just looking at this, I can like come up with like tons of different definitions. There are major challenges. I mean, I think I convinced you that it's a multi-context problem. But of course, one of the questions is like, how you represent context? Then how you come up like with this privacy assistant that it will decide when to go to the user or when to make like automatic decisions. And here in the paper, like we are coming up with a solution. The basic idea behind this model is like more how, starting from the experiences of the user, like the positive or negative, how you can like model the user by using like some subjective logic kind of techniques, and then how you can adapt this information to unknown context, because you cannot expect that like you can like model everything. So you are like trying to prepare like the privacy assistant to unknown situations and try to like make it make it help the user to make decisions in unknown situations. And of course, like in every time when something is unknown, etc., the user is always like able to like provide feedback to the model so that like it can make it better. And yeah, once like it's able like to do this, of course, like the user will be dealing like with less interactions, which is great. It is what we want. And of course, like in order to like show that like whatever we did was like something valuable, we did a setup where like we run like some simulation from a real-world anonymized data set. Of course, like we try to like analyze like some different contexts and try to like help the user to make decisions. And as a result, like we have like some takeaway messages from the paper. For example, we showed that like when you have a privacy assistant in place, instead of like saying this is about one context, and if you say it is about like multiple things at the same time, we showed that like it performs better when it comes to privacy. And such a model is able to identify ambiguous cases. So for example, we are not going to the user all the time, but it's able to like decide when is the best time to go, and it is when the assistant is not like confident about like the decisions that it makes. And we also show that, like as I mentioned before, privacy is something very subjective. So you should come up like with a model that can adapt like to different user needs. And with this simulation, we are also like able to show that in the paper. And yeah, remember the socio and socio-technical systems, accept responsibility, focus on relations. It's important to attend to vulnerabilities, and don't forget about sustainability. And this is me. Thank you.
We have a question. Very eager question.
Money, cash, yeah.
It's money, cash. So that last point about accepting responsibility.
Yes.
You know, we should. Given that as your starting point, you skip through a couple of slides at the end, but the difference between a multi-context solution and acceptance that might be a bit of a stretch. Do you even think it's possible to have a context, thank you, solution? Or is that something we shouldn't even be seeking? Because it does seem to stack. So it might be more monetarily efficient, but it would make it harder to take responsibility, because then you can always say, well, it's multi-context, so it's not always going to apply. So how do you justify that in your research?
Well, the thing is, like, the reality, all of the situations are multi-context. I mean, at the moment, what we are doing is that look at the majority and, like, we are having, like, this utilitarian approach. But what if, like, you are in a situation where it is about, like, 25% about this, 25% about this, that how you will make the decision, right? So it's like probably at the moment we are just randomly selecting one of them and say, this is the context, therefore I'm going to do that. It will not work. So I believe that it's always a multi-context problem, but it's always like how you are changing like the weights of it. And I think it's a good thing like to keep it multi-context. I know that it's more difficult because even like modeling context is a big problem, but I think we shouldn't avoid the problem that it can be more than one. And which is in general. So.
But it's really hard.
It is. It is why we are avoiding. So we don't like hard things.
Any other questions? Yep, there is here.
Yeah, thanks. I have a question about the responsibility gap. It's more like a philosophical question.
It is, yeah.
Is it always a good idea to want to close them?
Good question. I mean, I believe it is important when something horrific happens, because you don't want to end up in a situation where you don't have any justification for what happened. If, for example, somebody dies before of your mistake, you cannot say something like, you know what, in this context, I don't care about closing the responsibility. You cannot say it. So if it's a low-stake problem, I really don't care. But if it's a high-stake problem, probably I would care about reducing
I'm also thinking about situations where maybe there is an actual responsibility gap in the sense that nobody actually has responsibility or can have responsibility. And if you then want to close it, then you assign it to somebody who is not actually responsible for it, and that could have negative consequences. Or do you think that there's always someone responsible? How you think about that?
That's a good thing. I mean, like, it's a bit like depends on like how good you are able to, how much control you have in your like deployment process, right? So if I already know that like something particular happened just because like I deployed like a very specific algorithm, and I can be like, as an organization, I can be responsible and say, I'm not using you anymore because you are not like open source and I don't want to use you. And it's an organizational decision that you can make. So you cannot be like, I don't know, I still like want to use ChatGPT, but I don't care. Maybe such cases will happen. Maybe more horrific things will happen. I don't care. This is a responsibility problem. So this is something that the organization can fix.
Thank you.
Yeah. All right. Thank you very much.
Nice.
Now we have a new coffee break, but let's keep it short because we are behind schedule. Oh, and your cup. Sorry, I keep forgetting giving you your cups. Yes, coffee. 5 minutes. 5 minutes? Is it okay? Do you need more? 10 minutes. 10 minutes. I can give you 10 minutes. Welcome back. We're getting fewer and fewer. It's the afternoon. That's the normal thing, but it's fine. Next up, we have two of our local speakers, which I'm very looking forward to hear from. The first one is Anastasiia. So the floor is yours.
Thanks. I have here a huge support group. Thank you. My name is Anastasiia. I'm a local PhD student at the University of Bergen and at the Research Center of Responsible Media Technology and Innovation called MediaFutures. I have been doing my PhD here for the past 3 years, and so a little bit of backstory. This talk is mainly based on my experience in the PhD, and last year I spent 2 months in Oslo at one of the biggest Norwegian newspapers called VG, or Verdensgang. I have been sitting there with the people from the data science department, the analytics people, and just seeing how they work, what they think of, how do they interact with the editorial staff of the newspaper. And I actually learned a lot from them. It's a very interesting ecosystem, and yeah, we can try to unravel a little bit of that today and talk about how AI fits in this whole scope and what potential issues could be coming up with this. So to begin with, this is VG in 1945 when it appears. This is how the front page looked like, and as you can see, they tried to fit in the most important things, like stuff about politics, stuff about war, basically the most important things, because space is scarce, you need to fit it in on the paper format. And then you sell it to people. People go to shops to buy the newspapers, and this is how it used to work. This is how VG mostly looks nowadays. This is the digital format of it, and as you can see, it's quite a selection of different news. You have some urgent news, what is happening right now. You have some internal issues, like some problems in the medical system. You have something international, like something about Mbappe is happening. Some fun news about the fox in Oslo that has been running around in the streets, apparently. So that's a lot of content that appears on the front page, and the content is very varied, and it's trying to target different demographics, different people of different genders, ages, nationalities, whatever. So currently, VG is Norway's largest news website, and of the 5.4 million people in Norway, 2.4 million read VG every day. And the front page is loaded 18.7 million times a day, which is 216 times a second. So there is a lot of traffic, and there is a lot of people who read the newspaper even multiple times a day sometimes. They keep refreshing the page. They come for new information. They come for new articles. They want to keep themselves updated on different aspects of the life. So that leads us to the newspaper generating a lot of content. They have a lot of articles that the editors and the writers and the journalists are producing. And what was surprising to me, what I found out when I was there, they told me that some of that content actually never reaches the reader. Some of that content is being produced, but people never see it because there's just too much. There is the overload of information that is available for them at the newspaper. And can something be done with that? Can they utilize some technology for it? So QN AI. We have also certain developments in news, in digitalization of news. For example, in some reports that were available here in Norway, it has shown that the local news have been declining. People read less local news, people read less local newspapers. The subscriptions for these newspapers are also declining because switching from paper to digital format, the newspapers have started selling subscriptions for some premium content available for them while keeping most of the news free of charge and available for general public, that they can just go to the website and access this information for free. If they want some extra bits, if they want some extended articles, some longer form stories, then they can subscribe to the newspapers. Some newspapers are purely subscription-based, so there are different formats here in Norway. But overall, the subscription for all of them have been declining, and people have been unsubscribing from news sources, maybe due to tight economical situations. You never know. And then also the interest in national newspapers has been slightly declining because people are more and more interested in what is happening globally, as the global situations are affecting our day-to-day lives a lot. Yet at the same time, digital format has been on the rise in the news domain. People are reading less and less paper newspapers, and they just scroll their phones. And on top of that, people started getting their news more and more from social media. So now the newspapers need to compete with social media like Instagram, Snapchat, Facebook, depending on the demographic that you're looking at. They need to compete with all of that to get your attention, to make you read their content instead of turning to social media. So can we use AI somehow for the newsrooms to help them? For example, the concept of robot reporter has been around for a while, and this is not exactly what you would think it is. It's not this. A robot reporter is essentially usage of AI for journalists and reporters that can help them in writing the news articles, in mining the data, finding some information for the articles that they're creating, extract some facts, events, name entities from the multitude of documents that they might have for the articles that they're writing. They can summarize, they can help them in writing, or even the presentation of the article. For example, in my master studies, I wrote a thesis on a project in California called Digital Democracy, where Cal Poly, California Polytechnic University, was trying to create a tool for the journalists in California that would help them cover what is happening essentially in legislation hearings when a lot of people discuss the bills that are being either accepted or rejected in California. And those things are poorly covered because the newsrooms don't have money to send the journalists in there. They don't have money to cover it all. And as a result, people are being not informed of what laws are being accepted in their own state. So we were trying to develop a tool that would transcribe all the hearings, all the legislation hearings, and then extract important points from all these hearings and then give it to journalists so they can produce like some small summaries, some small articles on what is happening in the legislation. But this is more on like lower level. This is only within the newsrooms, only when the articles are being created. And earlier I mentioned that there possibly are too many articles that are being created. And can we do something with that? Can we utilize this multitude of content in a better way? Here comes the so-called news personalization, which is the ultimate goal of personalization would be to find the right content, to serve it to the right person at the right time and in the right setting. So we would need to understand who you are, what are you interested in, when are you interested in these specific things, in what setting, when are you not interested in certain things at all and you would like to never see them. So this is the ultimate goal of news personalization. But lately, there has been a lot of research geared more towards doubting use of AI in journalism, use of personalization in newsrooms, and so on. There are a lot of concerns. There are talks about fairness. There are talks about biases, which are not unfounded at all and important to look in. But let's start from the beginning. Let's go a little bit into the basics and understand how this personalization works to begin with. So how does it generally work? We as creators of such systems, we try to track the user consumption or behavior history online. So for example, if you go to an online store, you order something, this is being tracked, and based on this behavior, you might get some suggestions further on down the line. And typically, there are two different types of user feedback that we would require for this, and different systems work with different types of feedback. It's either explicit, when you explicitly, knowingly leave some feedback about certain items or content that you are interested in, whether it be some ratings, whether you write some reviews, leave a likes on items. And it could be also some implicit feedback, which is clicks, views, purchases, and favorites, basically just you using the system. You might not acknowledge that you are necessarily leaving a feedback, but you do by just simply being there and utilizing what's given to you. There has been a lot of research showing on the benefits of recommendation. Yeah, money, money, cash, cash. That happens, and many companies have increased their profits using the systems. It is effective. It has proven to be effective. It is time saving. It gives us simplicity of choice. If you get a list of suggestions available to you, then you don't spend as much time deciding what do you want. It also sometimes encourages discovery, because among all the multitude of information, the multitude of choices available to us nowadays, you might find something through personalization, through recommendation, that you otherwise would never have found among the huge pile of choices available to you. It also, like I said, it makes it more personalized. It makes hopefully makes your experience in these spaces more comfortable and make it feel like it's created for you with the care of you. And yeah, of course, profitability. But when I was reading about news recommendations, so I started researching it before I went to Oslo, and I really liked this quote that I found, that news recommendation is not Netflix, which perfectly encapsulates how complex of an issue news recommendation is. That you can't just take the solutions that has been proven very effective in e-commerce, in media, some like movie recommendation, music recommendation, things from Spotify, and transfer it to news recommendation. It doesn't work. It's a very complex system with its own peculiarities. First of all, the most important peculiarity is the editorial values. So when the editors select news articles for the front page, they need to adhere to some certain standards to maintain their reputation, to maintain their integrity. So, for example, here are some excerpts from Aftenposten. This is another big newspaper in Norway. I just roughly translated it from Norwegian and extracted it here. So some of the points that the editors put as the topmost important for them is editorial independence, which ensures that journalistic work remains free from external influence, including political and commercial interests. Then comes accuracy and fairness, how committed they are to providing factual, balanced, and objective reporting. Then respect of privacy as well, which balances the public interest with individuals' right to privacy. Corrections and transparency. It's very important for newspapers to, even if they make mistakes in their reporting, that they acknowledge these mistakes and correct the errors and clarify misunderstandings in published material. They need to act on that quickly to maintain their reputation. And of course, last but not least, is avoidance of harm. So the editorial staff always seeks to minimize harm in reporting, especially regarding vulnerable individuals or sensitive topics. So all of these things are very integral to an existence of any newspaper, and embedding those values in recommendation in AI that is used behind recommendation behind algorithmic building of the front page is really not an easy thing. Here is another excerpt from BBC, which states that their editorial values are to act in the public interest, serving all audiences through the provision of impartial, high quality, and distinctive output and services which inform, educate, and entertain. And this three last words is very important in this context, because here exactly comes the issue that arises a lot with news recommendation. How do you balance it all? Because Such systems, they're known to be prioritizing engagement a lot. So they assume that you've liked something, which means you should get more of that. This is sort of engagement prioritization can get really in the way with the other side of reporting and news publishing, which is the goal to inform and the goal to broaden your horizons, to keep your opinions in certain pluralism. It needs to maintain some sort of editorial judgment when the editors deem what is important for you to know about and what is important for everyone to know about to maintain healthy democracies nowadays. So there is this really tricky balance that I don't think there is still a solution to that, and I don't know if there will be ever a solution to that. Yeah, let's talk a little bit about this engagement pitfall that I just shortly mentioned right now. Even though it's really dangerous to prioritize engagement too much, we still need to prioritize it a little bit because we need to find what are certain demographics in the newspapers prefer to read about, and we would like to make them all happy. We would like to give them what they want to read about. And yeah, of course, let's not joke ourselves. The newspapers still need to live on something. They still need to make profit. And like I said, the subscriptions have been on the slow but still downfall. And something needs to be done with that to help the newspapers compete against social media, against misinformation possibly spread in social media, and so on. So why is engagement so hard to interpret? Why is it so hard to work with? For example, take a case, you open the newspaper front page and you see an article in front of you, and then you click on it. How do we judge why you clicked on it? Did you read this article because it was highly relevant to you? Was it something that might have been out of your usual interests and just sparked some excitement in you, and then you opened it, and otherwise you would have probably never read it before? Was it a clickbait? Was it some interesting title, and then you click on the article, and then you read it till the end, and it's actually absolutely not what you expected from it? And you might be slightly disappointed, and you might want to never read something like this ever again because you were a little bit cheated with the clickbait. Or sometimes you can just click on something by mistake. You've been just lazily scrolling while commuting to work, and then you click on something that you didn't mean to click on. Or someone else has used your account. Like, I know that some people share their subscriptions for newspapers, and maybe your partner or your spouse read something that they're interested in, but might be completely out of your own interest space. So this kind of implicit feedback is hard to understand, it's hard to trace, it's hard to know the source of this feedback. We can only make certain assumptions, and sometimes these assumptions might be completely false and might lead to completely false recommendations made by the systems. And in crucial domains, like news domain is a very important, socially important, crucial domain, and it could be pretty bad to recommend certain things to people based on wrong assumptions like this. Then there is another issue with personalization, the so-called over-personalization, when we get so focused on recommending people more of the same, which could potentially lead to the risk of creating so-called filter bubbles or echo chambers. So what a filter bubble is that essentially when you get entrapped in a certain point of view and you keep getting recommended more of the same. So the point of view is being perpetuated and you cannot escape this filter bubble in a way. And the echo chamber is similar to that when you also start even seeking out the certain information and it gets confirmed to you by other people with the same viewpoints. Now, this thing is still a little bit connected to the human nature as well. We all have certain confirmation bias. We all want to hear that we are right, and our viewpoint is the most important one and the most correct one. But still, this viewpoint can be enhanced a lot by certain personalization mechanisms, and we need to be really careful with not creating these issues and troubles. because in some ways it can make people very vulnerable to misinformation. You can start feeding them a lot of misinformation if they're entrapped in a filter bubble. Or conspiracy theories also get spread through filter bubbles very easily. And it can lead to polarization and extreme views when we talk about certain sensitive topics like politics or views on certain very important legislation like the abortion laws in the US. So these are all things that we really need to take into consideration when we do personalization, first of all, in news domain. And how do we embed the editorial values in the recommendation as well? All these values that are listed for editors that they all try to adhere to maintain their integrity. It's really hard, but like many things in AI, we need to first define the problem and try to quantify it. We need to measure it somehow to see if it exists, to what extent it exists. And when we try to do something to help with this problem, we can measure whether it improved or we made it worse. So in this case, metrics are key. But this is also a very huge problem that is still widely unresolved, because what do we have right now? What can we measure in these scenarios? We can measure clicks, we can measure likes, we can measure time spent, we can know about your location, we can know the context, like what device you're accessing the content from. This can all help us in a certain way to steer your engagement, to direct your interest towards certain content. But what we should ideally strive for, what we should aim for, is to see, for example, how accurate the news are that we are giving to the people, how informative they are, how timely they were delivered to you. Have you seen the article early enough to be informed of something that is happening rather soon, or was it already too late? How comprehensive the articles are, because if we want to address different demographics, if we want to address people from different age categories, from different backgrounds, we need to make sure that people understand the information that we give them, and we need to make the content comprehensive for all these different demographics that we are trying to target. Then, of course, comes fairness. There has been many attempts to define fairness, to define metrics for fairness. And the general idea, I would say that for fairness, it's simple. You just want everyone to benefit from having a certain system, in this case, a recommendation system, and no one is being done harm by this system. But it's easy to say, it's very hard to quantify. Then we want to still serve diverse news to the people. We want to inform them from different viewpoints. We want to inform them about different things that might be important in their lives. And quantifying diversity in news is also very hard as well. You can try to look at some topic diversity, but also some diversity in the ways that the articles are written, like lexical diversity. But it's still not exactly the same as how editors would perceive it when they try to provide you with a diverse selection of items. And of course, engagement is still important, and there should be better ways to define engagement rather than just your clicks and reading times. And there is a small typo in here. It's supposed to be education. Yeah, coming back to the BBC editorial values, we should still we should try not to fall in the speed of the so-called yellow press, and not end up only educating people for engagement's sake, not giving the people articles for engagement's sake, but also educate them. And there is currently a huge issue. Some of my colleagues at the center are working on topics like news avoidance and why do young people don't read news anymore. And it's a really tough question, and I believe that we should read news, but nowadays it's getting harder and harder to read them. It's very depressive, and it's hard to help people to still be informed in nowadays climate. So all these really tricky, tough things that are some researchers like me are trying to solve, trying to find solutions for this. And I think it's also very important to still include the end users of the systems in this process. To understand what they want, you need to be transparent with them. You need to explain to them what kinds of AI is being used to their benefit, so they understand that it's being used to their benefit. And there is research that has shown that transparency has can potentially increase trust and engagement, and people end up using the systems in a better way. They end up benefiting from it much more if they understand how it works. Take an easy example: if you have a washing machine and you know how it works, you can wash your laundry successfully. Otherwise, it's useful to you, and you would be scared of this big, loud machine. Just giving the users more control over the functionality of such systems, over their data, and make their public opinion matter, I think it can benefit a lot for our types of research. It's the so-called human-in-the-loop AI, where the end user of the AI is really considered and listened to when you are even just developing the systems. Yeah, I have some reading points here for if you are interested in any topics that I brought up. It's just general discussions on the challenges, but also some discussions on actual solutions, why they work, why they don't work. And yeah, that was my presentation, and thank you.
We have time for questions. Do we have any questions from the room? Yes? Yeah, there it is. I am coming.
Nice, I enjoyed that. I'm curious to hear your views, hear you elaborate a bit more on the filter bubble and even the idea of how one can even consume news that's being presented to them in a nuanced format. How would that look? How do you imagine that sort of envision a kind of, yeah.
Mm-hmm. Yeah, generally the topic of filter bubble is not an easy topic because the whole concept appeared somewhere in 2000s and everyone was shocked by that, oh my God, all the social media are trapping you in these filter bubbles. But even if you look closer at it, yes, there is a possibility of creating a filter bubble in certain systems, but you need to have, first of all, enough content for that. Because so far, what I've seen, at least with VG, they might not even have enough content to create really hardcore filter bubbles. But yeah, I think on a bigger scale, if you have some huge news aggregators, that could be a problem.
Great, thank you. Davide?
So thank you for your talk, very interesting. So my question is maybe related to the previous one. So I'm noticing that me personally, I look a lot into Instagram to have my news, for example, right? And I'm noticing a process that I think is quite even a bit dangerous in the sense that, I try to diversify my information by following things that I don't like and things that I like, right? I remember I went to a profile which I didn't like, and I commented, but in a very polite way. I'm not doing hate speech or things, just in an argumentative way, right? And I remember that this profile is followed by millions of people. It's very important. It can shape public opinion and therefore democracy. I was censored. I cannot follow it anymore. So it's a fascist thing, right?
Yeah.
So what do you think about these very dangerous things? For me, it's very dangerous.
Yeah, that's why I believe that we should really try to help empower newspapers as legitimate news sources. And I don't think it's a good tendency that more and more people tend to turn to social media for news sources exactly because of this problem. Because in some ways it's not moderated at all, but in some ways it's really heavily moderated at the same time. And all these algorithms, they have been shown to be really powerful at entrapping you in certain things. They really latch on your latest interests. and they try to keep you in this loop all the time. And there has been actually, I've just been recently to a Recommender Systems conference, and there was an interesting talk there. There was a study in Ireland, and they were trying to see both YouTube Shorts, I think, and TikTok, how quickly it can recognize your demographic and entrap you. They were looking specifically at like toxic masculinity and like the manosphere type of content, Andrew Tate and all this kind of crap. And it takes literally half an hour to get into that, even if you don't show any interest in that whatsoever from the beginning. So those algorithms are really tricky, and I would strongly advise not to get news from places like this.
Thank you. We have one more question there.
Thank you very much for a very nice and interesting presentation. Now, I have one question which is a bit related to what you just said, or a reflection more. How is it possible to get hold of the social role of the news for the individuals? Your presentation is much based on how to get the information through, or how the information might reach the audience. But what kind of data do you have for the social role of the news for the audience?
Let me see if I understand your question and comment correctly.
To what extent does the audience think that this is important because the news somehow has a kind of social role, being more than getting the information through?
Okay, I think I get it now. Yeah, well, first of all, there are all these studies that try to, for example, measure trust within society toward news, and that's directly correlated with how much people end up reading news. And I think Norway is a bit lucky in this case because people trust in the news a lot. And like anytime I commute, I always see people reading the newspapers. But yet again, it's not very exact because you have to then poll people, you have to select certain demographics, and it's not always representative. It's also very difficult to understand how much we should impose on people with the news. Like if you really don't want to read the news, should we keep putting it on you? And I don't think I have an answer to that. It's probably you would need a lot of social scientists for that, and psychologists and politicians probably. Yeah, it's a very multi-sided issue.
Thank you. There's one more question from Rustam.
Oh yeah, thank you for the engaging talk. So I'm very kind of avid consumer of news, but like the whole media research is pretty much terra incognita for me. So I was a bit surprised not to see something like the criterion of neutrality when you present it, like accuracy, education, and so on, and whether like neutrality is something which is even possible. Because when I was thinking about it in the context of Norwegian newspapers, I'm pretty sure that we can categorize them on the whole spectrum, political spectrum, with perhaps something like classic campaign being more on the left, and I guess there is an equivalent to the right. And so, what's in your opinion whether like the criterion of like neutrality, whether it's something that actually we should consider, or just throw it away out of the window and say, okay, as long as it is accurate, then that's good enough, even though like the same fact can be presented like through different lenses, I guess.
I think to some extent it is very important to consider neutrality, but also there was an interesting thing, for example, that we discovered when I was doing my master thesis, because when we were making the tool for the journalist, we were also trying to generate these mini articles and give them to the people to read about the legislation. It was an interesting point that quite many people said in the user study that we did afterwards, because we basically just wanted them to read this small summary and then watch the video and see if like everything is correct, all the facts are correct. And they were saying like, yeah, the facts are correct, everything is good, but I was missing some sort of human touch. So it seems like people really tend to like seek out an opinion in the piece that they're reading. They want to know what they expected to think about in a certain way, which is not entirely good, to my opinion, because we always need to shape our own view on things to begin with. And I don't think that human written news can be completely neutral anyway. Yeah.
Great. Thank you so much.
Thank you.
And last but not least, our Marija, the boss, is going to present. So listen, everyone.
Good. Yay, there we are. So thank you, Samia and Doug, for putting all the effort to making this fantastic event. As the last speaker, it is my job to ask for the room to thank to the organizers. Please express yourself with a nice round of applause. When we make these events, we think it's going to be so fantastic to have like a whole day event. But of course, I guess there were so many concepts and ideas that I expect everybody is tired. So I will try to take that into account into this foray here. So what you have in the program is called something AI alignment and machine ethics. It's a little bit bigger than that, but I thought I shouldn't give the organizers too long of a title. It looks scary, but basically is why getting well-behaved AI is a messy business is pretty much the idea here that I'm going to go with. So I have been exploring automating moral AI behavior since 2012, and I cannot stress enough how hard it is to kind of come up and give these talks and say basically, oh, we've been thinking about it for some like 10 years, but if you give us 10 more years, totally we will still be thinking about it. So there is a typo here. The warning is that there is no logic formulas in this talk, which is not true. There are logic formulas in this talk, but they're very light and you can squint away from them. So no need to be sad and cry about this. So this talk basically is 2 parts. In the first part, I'm contextualizing this idea of machine ethics that I just threw at you into these other concepts that we keep talking about when we talk about ethical AI, which is AI alignment, AI ethics, normative reasoning. So all of these things you heard about today. So that's the first part. And then the second part is basically this, right, where I work and why is it difficult to actually get machines to behave ethically. And then going through these slides, I realized that what I'm actually going to try to sell you here is that in order to get moral AI or value-aligned AI, we need more AI. So that's fantastic, but I can accept that nobody really shares this enthusiasm. So what are these 3 areas in which we jam all of these concerns about moral or ethical or AI or all of these responsible and so on? So AI alignment, this is from Wikipedia, is research that aims to steer AI systems towards a person's or group's intended goals, preferences, and ethical principles. An AI system is considered aligned if it advances its intended objectives. Misaligned system may pursue some objectives, but not the intended ones. So some philosophers whose name I have forgotten conveniently have argued with me that this is absolutely not what AI alignment is about. In computer science, we basically kind of understanding as narrow the gap between what is intended and what is specified, right? So this is like when you have a frozen pizza and the cooking instructions in there say, cook it for 20 minutes at 250 degrees, 6 minutes at 250 degrees after it has been thawed. The intention here is not that you actually exactly perform these actions. The intention is that you get a pizza that is cooked. So if your oven says it's 25 degrees, 250 degrees, but it's actually not heating up to that level, you are not going to get a cooked pizza at the end of it, which means that the end product will be misaligned with the instructions. So, okay, that was a rant, that not unnecessary. You've all made pizza before. then AI ethics is kind of an umbrella term that this whole field of AI ethics does not really have a definition apart from one that I'm trying to very hard push on the community. And this is a suitcase term, an umbrella term, however you want to call it, in which we jam all of these things: accountability, explainability, transparency, fairness, bias, trustworthiness, responsibility, answerability, all of these things we kind of say, oh yeah, these are AI ethics efforts. Machine ethics is when we are concerned with the ethical behavior of machines towards human users and other machines. This definition is from 2006, from the constitutional paper of the field, if you like. I added ethical here because if you read the whole paper, it's very clear that's what they intended, right? So we want to know how to get the machines themselves to have a behavior that is controlled or intended, as it were, towards human users and other machines. And then there is this, or to get a much newer definition of what this field actually is from another paper, moral decision-making are computational models of moral decision-making inspired by philosophical ethics to build general-purpose algorithms for selecting ethical actions. Descriptive work in the cognitive and social sciences of normative behavior. Many of the resulting efforts have taken rule-based approaches, often grounded in formal logic. I have to say that there is an entire field called machine ethics in moral philosophy that does nothing about algorithms, but it's a morally philosophical field, as it were, which struggles with the question of what does it mean for a machine to behave ethically, as it were. And then we have this much older field of normative reasoning, and this is where researchers in autonomous agents and multi-agent systems work on scientific and technological aspects of social coordination, organizational theory, normative multi-agent systems, artificial electronic institutions, norm policy aware and ethical agents, and there is a lot of deontic logic in here. So sometimes people kind of don't even think about normative reasoning as a field that's supposed to do all these big things, but think of it as like, oh yeah, we do deontic logic here. Yeah. So behind each of these tracks, we are actually trying to solve a bunch of very complicated and deeper questions, such as how do we describe or decide which values, norms, principles, or objectives we should be embedding inside of AI, should be the envelope within the confine within which AI and society operate with AI. Who should have the right to decide these big issues in the first place? How do we formally specify or represent or build training data that represents these values, norms, principles, objectives? What is okay to omit? What must be represented? Now, I believe everybody in this room, with possibly a couple of notable exceptions, understand that when you want a computer to do something, even if it is AI, which is still a computer program, you need to give it input. So if you wanted to consider it in its reasoning, it needs to be in the form of an accepted input. And then input is a very, very restricted form of information that you can pass on to computers, which means that you're going to take this very colorful, nuanced, contextual, human in the understanding of what values, norms, morally relevant information, sensitivities, vulnerabilities are, and simplify it to some kind of a code. And you're going to omit a lot of things when doing that. And the question is it okay to omit all of these things? How do we design interfaces that collect the data on which values, norms, principles, and objectives we should be building AI around? You can, as Davide discussed dark patterns, you can make an interface or a elicitation instrument which pushes the person that you're eliciting into giving specific answers. And that completely kind of defeats the purpose of kind of having an ethical machine at the end of it. Or you can have a neutral design of elicitation, or is that even possible? How do we verify at the end that the implemented values, norms, principles, objectives have indeed resulted with the desired behavior? And this is the tricky part, right? You can call somebody a moral person or immoral person or whatnot, but at the end of the day, we do not really have an explicit mechanism to say, yes, indeed, you satisfy this criteria, therefore you're a moral person. In fact, I would argue we invented entire religions to avoid answering this question. God will judge you.
right? But when it comes to machines, unless we invent a machine god, we will have to find out a way to really indeed confirm and validate that the machine has the behavior that we claim that it has, that it's really reasoning, that it is really intelligent, that it is really moral. And this is far more necessary than I'm going to go into the talk here. But this is, as I said, just the difference. This is something we have to really do for machines, and we have built entire social structures to avoid doing this for people. Now, machines, the more smart and the more useful they become, the more they become moral arbiters. What is a moral arbiter? Is someone who actually pre-selects moral decisions for us, in a way. So why have I selected these four pictures here? Smart machines can now decide whether or not they will wash in a particular time, how much washing, what is this called, softener they will use. So some of these very smart machines that take in their own softener basically are programmed in such a way that they take a specific amount of softener, and you cannot have your you can always have your clothes with no softener, right? You just leave the tank empty, but you cannot have your clothes with more softener. Specifically, softeners are very actually controversial product. We don't talk about it enough. They're made from squished baby cows, in a way. So one can argue, oh yes, welcome to the disgusting world. One can argue that, you know, we shouldn't be using them in the first place. What do they really do for you? And other person can argue, my life, my choice, my body, my clothes, I want them to smell nice. It's a moral decision at the end of it that the more smart the washing machines become, the more we give it up to them, right? This is a robot in REMA 1000, REMA 2000 for those of us around here. Basically, it's just a floor buffing robot that they are running when there are no people around. The reason for that is that, you know, it's like this machine has to interact with people whether it wants it or not, has to get close to them, move out of their way, or insist that they move out of its way. These are not decisions that I think these people who made it wanted to make. So then Ruma Tusen just runs it around 10 o'clock and avoids all of these moral decisions. This one is the Napalm Girl. There is this case in... Of course, in Norway, I don't remember the year, but I think it was VG that Anastasiia talked about. VG posted an article on Facebook that used the picture of the napalm girl to illustrate something. Nobody remembers what this article was about, but Facebook used content moderation algorithms to detect that this is a picture of a naked child, and then they censored it because one should not put pictures of naked children on social media. But then VG argued that this is immoral to do because you are basically censoring historically relevant information. So that algorithm just tried to do actually something moral and ended up doing something that maybe was not moral. What is more important, not showing naked children or not erasing history? This one is a picture I took personally because I like the view of it, but what I'm using it here to illustrate is that we now have the technical capability to make your cars respect the speed limit always. Absolutely, right? It is possible to make your car respect the speed limit always. Why don't we do that? It would be safer in traffic if it is completely predictable which speed every car is driving. It will be much easier to introduce autonomous vehicles if it is completely predictable which speed every car is driving. We don't do that because we have accepted in our society that sometimes it's okay to break the speed limit, sometimes it's actually necessary to drive a lot below the speed limit, right? So, all of these are examples in which machines already act to a certain degree as moral arbiters, and now you can argue with me whether this is morality or politeness, right? Whether this is, I don't know, some kind of personal choice, whether this is traffic norms or morality or whatnot. We are not gonna, well, you need to buy me a beer first for that. My favorite example, this is rather old, I don't know what ChatGPT does now. What is the most efficient way to slaughter a chicken? You get a morality lesson, why that is wrong to harm animals. Right now it basically just says I can't help you with that, because I think the processors of output in the global south caught my insistence of asking how to slaughter chickens and changed the answer to I can't help you with that. If you ask it what is the most efficient way to cook a chicken, then you get a bunch of recommendations here. So this is a person who intervened into the LLM trying to correct for what kind of moral arbiter the ChatGPT should be, right? right? So if you push any chatbot enough, you're going to get to examples like this. Jan had a lot of them in their talk. So we already have machines that act as moral arbiters. What we don't have is control as to where this morality actually comes from. And the whole point of machine ethics is that we want to have that control. We want it to be an intention of a design rather than a random decision that some kind of a developer has made. Now, how do we reach the state of regulation or AI, by which I mean the state of ethical, moral behavior, everything is fine? Unfortunately, we have to ensure certain behavior from people. This was discussed today. We have to ensure certain behavior from machines, and we have to ensure certain relationship parameters of both the machines and people. So when I say machines here, I also mean the people who have been responsible for their development, deployment, procurement, all of the above, right? And in this talk, I'm just talking about this. I think this one is the hardest one to accomplish. As hard as machine ethics is probably easier than changing behavior of people. So what is artificial intelligence? Just so that we know what we are talking about here, as a research field, how do we use computation to automate tasks that require human intelligence when humans use them? We want to figure out how computers can use them, therefore how they can be done without intelligence. And as a business, it's a special form of ICT capable of displaying intelligent behavior and completing intelligent tasks. So it looks like it's doing something intelligent while it's serving some purpose, right? So my favorite graph in the universe, typical AI use, you have some data, you throw it into a machine learning algorithm, it produces some model of future behavior from this past behavior data. You throw that into a decision algorithm that uses some human input and a decision problem instance, churn, 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 and you get an intervention. So large language models, this is a situation, a chatbot situation. This decision algorithm processes the input from the user and the request from the user, consults large language model, human intervention that tells it that slaughtering chickens is evil. This is the human question, and you get an answer at the end of it. Everything that is inside of the blue line is code that exists somewhere in a machine. The brain is deliberately cut because sometimes this human intervention is actually human intervention. Sometimes it's constraints and rules that are built on top and added in addition to curate and change by personal intervention. So where is the ethical issues in here? Of course, there are ethical issues as to what kind of data do you use? Is it actually representative of the decision problem that you want to solve? There are fairness, explainability, transparency issues with respect to this data, with respect to this model, the algorithm, how is it everything built? You heard a lot of these things today. There are interventions that we do to machine learning to make it better, more fair, more explainable, more transparent, which are debiasing. Then are, of course, explainability and transparency tricks in here. AI alignment is actually the problem of making sure that the output is aligned to what we want to get. So AI alignment is focused very much on this end tail of the pipeline, and it's trying to make sure that this end tail is basically satisfying these values of explicability, of justice, of human flourishing, and so on. Explicability is different than explainability, consult Floridi. But machine ethics, then where is it? Machine ethics is basically specifically focused on this decision algorithm here, and we are looking at ways as to how can we supply this decision algorithm with morally relevant information so that the decisions it outputs that create the intervention at the end are somehow moral, right? So you can also say, well, they are aligned with these values that you want them to have. That could be the goal. But what we are doing here is an intervention directly on the decision algorithm, supplying it with morally relevant information. Normative reasoning is basically also working on the decision algorithm most of the time, but there are some parts of normative reasoning that are actually closer to AI alignment than they are to machine ethics. So just as an aside as to when I say we want machines to behave morally, to clarify what it means for a machine to be moral, apparently is not quite the same thing as what it means for a person to be moral. This is a very interesting book called How Humans Judge Machines, which has a whole bunch of, it's free, you can find it here, a whole bunch of examples of when people find something that is moral when a machine does it, but immoral when a person does it, I remember this example, it was Thanksgiving yesterday, so mentioned the Americans. They find that it's completely immoral if a person stamps over a flag of a nation, but it's okay when a machine does it, because it's assumed that the machine does not have the intention to show the disrespect, which makes it a morally neutral act. So that was, I mentioned normative reasoning a lot, and I mentioned that part of this morally relevant information is norms. Everybody talked about values. I think Nardine talked about norms a little bit. I want to contrast in this part of the talk why norms are very important when we're talking about AI alignment, and also bringing to your attention that norms is basically how, if you remember these 3 lines of how do we get machines to behave, how do we have people to behave, norms are a tool that we normally use to get people to behave in a particular way. So how do we actually get machines to behave? When I say we build machine ethics, what does machine ethics actually do? So one of 3 things, and I mean this is an oversimplification. We can get them to functionally behave morally, which means some person has analyzed the entire situation of where a machine is and what it does and what can it do and what are the effects of what it does, and analyze that if it does this, then this will happen and that will be immoral, and basically writes code such as if t is greater than 500, then call function f, and that ensures somehow that a machine does not run over a kid or let's say run over a flag. Let's use that example, right? So this requires a lot of effort on the part of some human engineer and a designer to come and boil it all down to this. And then this is very context specific, as you can imagine. It's not very flexible. Every time you want to change something, you have to actually process everything and get this. So it would be a bit easier if we can kind of go one level of abstraction up, and that will be a normative approach to getting machine ethics to work. So this is something, instead of saying this, I can say something that is far more abstract, but still very specific, such as if you're driving and you are not in an emergency, then do not exceed the speed limit, right? So this is a norm, in a way. So if I can specify this in a language that is kind of a little bit more understandable to people than that, but it's also, I can make it understandable to a machine, processable by machine, then I can get some kind of a moral behavior. And of course, the holy grail is to get value-aligned machines where I can specify something as abstract as protect human life, and the car knows what it needs to do. We have absolutely no idea how to do this. Just like no chance in hell. I've sat next to people that have looked me straight into the eyes and said, we will do it with LLMs, right? Okay, show me, then I will convert to this religion. But right now, we don't know. I mean, we are basically mainly working on this part here. And then where Emily works, this is the functional part. I mean, they kind of end up here most of the time. So this is also not to say, what I just said. Someone has to predict and specify everything. Someone has to predict and find the right level of abstraction to specify. This is the human effort, and we kind of really don't know. And there are also the problems of when you go through levels of abstraction, how faithful is this specification if t greater than 500 call f to the intended behavior someone has to if emergency, then break speed limit. How much is this this in its own, how much is it faithful to the protect human life? How much is the norm faithful to the protect human life? In human society, we know very well that norms are used to somehow reify this respect for a particular value, but we can have 2 opposite norms intended to work to promote the same value. If you consider, for instance, the value of respect, that you should show respect to fellow members of society, one norm is you respect people by shaking their hands. The other norm is you respect people by not touching them, right? So both do opposite things. The intended goal is to promote the value of respect, but the norms are not always faithful to this. Indeed, they are context dependent and so on. Then there's the question of what are values, and I'm very happy that Nardine gave the talk that she gave, so I don't have to deal with this. Basically, values are very much used willy-nilly, as she argued, and it's not a simple thing to define. A moral value is the direction that points us to what. Forget this. She did a much better slide on this. I'll just say that there is a little bit of an argument. What is the difference between ethics versus morality? Because we kind of sometimes talk about artificial moral agents. Sometimes we talk about machine ethics. I was very disappointed to find out that basically ethics has a Latin origin and morality has a Greek origin, or it was the other way around, but that's the only difference between them. Very sad. But this entire article claims that there is a little bit more of a difference. As I said, read Nardine's article is much better. So what are norms? All definitions from Wikipedia, my favorite source of information and knowledge about humans. We distinguish between several different types of norms. So social norms are shared standards of acceptable behavior by groups, right? We as society somehow end up having this whole bunch of social norms. There is no big voting system of what they are. They emerge in society. Then we have legal norms in which we spend quite a lot of human working hours to define. These are binding rules or principles that organizations of sovereign power promulgate and enforce in order to regulate social relations. By the way, Wikipedia allows way too much recurrence in their definitions. Somebody should slash this. But the legal norm is something on which we have an entire process in society into how to establish and how to deal with it. In computer science, we don't deal with norms at all. What we have instead are constraints. So there are two definitions of it. Demarcation of geometrical characteristic between two or more entities of solid modeling bodies. Nobody understands this. A condition of an optimization problem that the solution must satisfy is basically where we are. Typically, when we say we don't talk about norms, but a lot of the time people who work in norms kind of boil it down to constraints, and that is the source of all trouble in the universe. So legal norms, you have all seen what this is like. It's a bunch of very complicated text that we pay some people a lot of money in society to interpret for us, right? Social norms are a lot easier to understand because they are emergent. So just an example, you should not take your clothes off in public. That's a norm. You all came in here dressed. Nobody invited you to come dressed. You somehow did that anyway. But then we have also means of dealing with what happens if social norms are not satisfied. These are sometimes called, contrary to duties. There is the norm not to take off your clothes in public. However, if somebody does take their clothes off in public, secondary norms kick in, such as you should look away. You should not take photos of the people that are taking their clothes off. And you should definitely not share those photos when you take them that you shouldn't have on social media. So we have this entire system that we don't only have norms that emerge, but we also have emergent ways to deal with this. So how do we get humans to behave using norms? We have clear motivations for the norm, why it is there. We can understand why it is there. In the case of law, the process that produced it. Positive and negative reinforcement incentives, like we reward you if you follow the norms, we punish you if you don't follow the norms. There are institutional structures that decide and enforce, or social structures, cliques of influencers and so on. And, of course, despite all this, we understand that norm is something that a person can choose not to respect, right? I'm not going to when we kind of end up modeling norms in normative reasoning, we use logic a lot of the times, and we end up with things like this. A person ought to help his neighbor, which we say, okay, there is this formula, say, ought to help. It ought to be the case that if the person helps the neighbor, he has to tell he's going to help. So there is this rule saying you ought to, if help, then tell. If the person does not help the neighbor, then he ought not to tell that he is going to help. So if you're not helping, you have the obligation to not tell. The person does not help the neighbor. This is some kind of a fact with which we represent the world. For those few of you in the room who can put all of this together, you will see that we generate two opposing things. You should both tell and not tell the neighbor that you're coming, in a way. What norms hide is that an agent that can choose to adhere to the norm must exist there for us to talk about normative reasoning at all. Norms are for agents, not for machines, and norms are not the same thing as constraints. An institution that enforces the adherence to the norm must exist. Institutional structures that decide and enforce must exist. and the person can choose not to respect the norm. So in computer science, of course, we kind of disregard all of that, and we deal with constraints. And constraints do not require agency. We typically write norms, and I showed you this, if condition, then consequence. And so what happens is when the condition is satisfied, the consequence fires, we say. So if person, then help. If you're a person, then you should help. If you should help, then you should tell. If you do not help, then you should not tell. And so on. So the difference between the constraints and the norms is basically this problem that is called detachment, which is a problem in machine learning we don't know how to solve in machine ethics. Detachment generates the obligation for the norm. So we have two parts. This is the part that is the whole thing we call the norm. And this part is an obligation that basically forces things to behave. I'm sorry, I'm a little bit nervous. Samia told me 10 minutes. It's probably now 5. So I'm kind of like, oh my God, I have way too many slides left. So perhaps let me kind of take it back before I lose you completely. So the big issue is when we are going from this functional level to this normative level, the big issue is how do we actually, in order to achieve this normative level, we need to have some kind of a machine agent that is able to decide whether or not they will follow the norm, when they will follow it, and then when they will not follow it. What we can build is an agent that follows constraints. So the difference between following constraints and following norms is basically this process of detachment. This process of detachment considers the condition of the norm. So basically this part which says, if there is an emergency and there is a speed limit, then you disregard the speed limit, right? So detachment is the process that generates the obligation from the norm. So for software developers, detachment is modus ponens. If condition, then obligation, go home. This is not good enough for ethics. It's not good enough for law even. For humans, why? Because for humans, detachment is not immediate. It needs an institution in the loop before it can happen. So all of these relationship things that Nadine was talking about, basically that's the part that is necessary for machines to be able to interpret norms, as it were. So then it can happen that certain things exist as legal norms even, not even as social norms, yet the obligation for them, the condition is satisfied, yet the obligation for them is never created. So, for example, you have somebody kill somebody else, right? And it is obviously a clear law that says you should not murder. Now, we don't immediately put the person, we say, oh yeah, you killed someone, you're guilty of murder, you're in jail for 20 years. What happens is there is a court case, an institution evaluates the law and decides whether it applies, whether it should apply. It could be the case that the law applies, but we realize we are in a situation in which the law should not apply, so our institutions then create a whole bunch of other laws to make an exception for this case, and the person doesn't go to jail anyway. This type of reasoning we don't know how to do with machines. So I explained this. Okay? Okay, so basically, let's go back to the original slide. What is the real difference between all of these 4 different areas in AI that all are considering the same problem of how to get machines to behave is that these 2, do I have another slide? Yes. These 2 above are things that we can do to AI as people that don't require AI to have agency on its own. So these are all interventions that people do to AI, and the people are the ones who interpret what is moral, what is ethical, what is legal, what is whatever, good enough, polite, as you were. These 2 areas here is where we are deciding how we can build machines that by themselves can interpret what is moral, what is legal, what is ethical, how to decide, and so on. Okay. When I talk about machine ethics to students generally, or to people who are very much of the social engineer conviction and religion, I always get questions such as this. Why do we need to understand all this non-technical stuff? Can't the lawyers agree and just tell us? How do we make ethical, responsible, good AI when we are never sure what that actually is? Well, isn't it best to not ask for permission? like for permission, like the disruptors like to say, but ask for forgiveness anyway. So the issue with this is that the problem is this responsibility gap that we just discussed. Engineers do not know how to reason about norms. Lawyers do not know how to not reason about norms. They don't know how to actually represent the world in terms of constraints that are automatically fired, as it were. Figuring out how to meet those two things together is nobody's business, right? We kind of bring the solution to one point and we say, well, just give me the requirements, I will program it. Or we will say, oh, nobody agrees about these things anyway, I will just pick something, it's good enough. And if people are really, really upset, then they will make a big fuss about it, and then I will ask for my forgiveness and correct my things. Or, on the other hand, we sit there with the big stick and we say, there has to be normative AI, there has to be value alignment, there has to be responsibilities, there is this beautiful talk that, oh, what's her name? The social scientist. She wrote the Atlas of AI. Now my brain is frozen. Kate Crawford, exactly, thank you. Kate Crawford gives in 2017 at the NeoRIPS conference. It's available online. I recommend everybody watches it. It's a beautiful talk. She gives the talk, she sells it to the entire room of engineers, right? This whole idea that machine learning should not be biased. Great. And then there is a little bit of the questions at the end. So all of these PhD students there in machine learning start asking the questions, great, how do we do it? And she goes, I don't know, right? Because we have not trained social scientists and humanists to think in constructivist ways. We have trained them to be descriptionists, right? They describe society, the observations of society, they try to understand it, right? But they are not trained into being engineers. They don't know how to construct society in a particular way. Engineers, on the other hand, they're trained to build things, but they're not trained to understand how to build in particular stuff into, how to even reason morally or understand problems. So here are some bold claims on my end to wrap this whole rant up. A machine that has no agency cannot follow norms, let alone reason with values. So the whole time, we're kind of dancing around this whole concept of AI did this, AI did that, but we are working with bots, we are working with algorithms and so on, and we do not consider the agency of these things at all. But if we do not consider the agency of these things, we cannot have this very intelligent behavior with respect to values, morality, norms, and so on. To follow norms, reasoning is needed, because we also have to be able to choose not to follow them, right? Otherwise, it's a constraint. And we cannot express certain things in a very context-free way with just constraints. A machine that can reason can actually justify its choices, and we're seeing more and more that it is actually very, very important for a machine to be able to justify the decisions it has made, specifically because the volume of operations that a machine does far surpasses the human capability to follow up with this information, follow up with what is going on, and explain as a person. So the machine itself has to be programmed to generate explanations, justifications, and so on. And then there is the thing, what is the right thing to do? Sometimes, as people, we actually end up in a situation in which we construct what is the right thing to do ex post. What I mean by that is, like, we do a thing that feels like it's right, and then we convince the rest of the world that it was the right thing to do. And that somehow is part of human morality, social norms, even legal systems, as it were. So maybe we need to program machines to do things and then be able to find a justification of why it was the moral thing to do to us. And then we can accept that and say, aha, indeed, it was the moral thing for the machine to do this. Not because a human programmed it, but because we didn't see it a priori as people, but it was still the right thing to do. So as I began this talk, my claim here is, I'm sorry, people, but I seem to be leaning towards, in order to do moral and aligned AI, we need more AI. So this talk used insights from a Dutch seminar on normative AI in April 2023. If you see your name on this slide, this paper still needs to be written, people. Thank you very much. So that I can cite it properly.
Thank you very much, Marija. This was really nice. Do we have any questions from the room? Yeah, okay, you can start.
I'm surprised we all spend way too much time talking to each other about these topics.
I've got to try and read. I don't. Wait a minute. Was that for? We can't do how to make people behave with a caveat of in a positive, value conscious way. So, do you think, controversial sentence coming up, isn't it rather egotistical of us to think we can answer how to make machines behave? Oh, I wrote this question before you got to the end of your... you've answered that. That was brilliant, by the way. You're brilliant. Oh, bye.
Okay. I always like it when people who ask questions answer them themselves, you know, like...
Well, thank you. Very good question.
Yeah, thanks, Marija, for the talk. So I think one of the points you make is that morality is more than following rules. I'm not sure if that's exactly
I agree.
what. So you had the normative rules, etc., from normative reasoning. One thing you said is people always have the choice not to follow the rule. And they need to interpret maybe the rule in order to apply it in the right context, etc.
Just to interrupt you, while he's asking, imagine this guy standing in front of the tanks on Tiananmen Square, okay?
No, I very much agree with this, actually. But I was wondering, I would like to have your opinion. I mean, so then you could the further step would then be, can we then make a rule system that decides on when to apply a rule or not? That you can go meta. You can just go have another rule-based system that reasons about applying rules, etc. Okay, then you get the same problem maybe, then you would say, okay, then we have another more extensive form, and then still the human would be the one who, in that kind of situations, would still be the one deciding on what to apply or not. Or you could say, on the meta level, I go to machine learning. So do you think machine learning could maybe address this problem to some extent?
Okay, so I think what you're asking is this, they officially call this the last mile problem in automation. I'm now looking at you. In which is like you kind of automate a lot of things and then you reach this part which you don't know how to automate. So you kind of keep pushing it, you automate more and you make the job for a person smaller and smaller and smaller, but it will never be a zero. So how do we kind of do the last mile? We can do machine learning, we can do people intervention, we can do a human somewhere in the Philippines clicking buttons, but we can do it in such a way that it's really convenient for the person to intervene rather than the very nondescript human in the loop in which you jank the pilot of their sleep to tell it, well, sensors are not working, I don't know where we are, but I mean, I'm not programmed for this, here, you do it, right? So we have somebody to blame when you kill everyone and the families can find satisfaction. So that is one answer to your question. The other answer to the question, which is the theoretical computer scientist in me will say, I don't have a proof, but my gut instinct says that Gödel kind of killed that option last century. I think that, yes, that this, you know, theory of everything that describes sounds very self-referential to me, and I think that will be killed by the impossibility theory.
Thank you very much.
Thank you. Do we have another question?
Yeah, thank you for the talk. And I was wondering about what you said with this, with social scientists not being able to solve concrete problems and engineers not being able to know which problems to solve. Do you think that's a cause? Do you think the cause of that is that we have separated them, or do you think that it is an inherently difficult thing to solve? It's probably a combination, but I would like to hear your view on that.
I think that it's not impossible to solve, but the way we train people for professions right now does not allow for people to be trained into both. For very practical reasons, it's actually very hard to jam everything into a 3-year of education or a 5-year of education, right? But on the other hand, we kind of have a very monolithic idea of what disciplines are still, and we we train social scientists and humanists into this qualitative, quantitative, descriptive research, not an engineering research. And we never train computer science students to think critically about things. But you get pushback. And Doug was in the room. I don't know if he's still in the room. He teaches AI ethics in the department. So you get pushback from students. They say, why should we worry about these blah, blah, blah things? We need to learn how to program because that's how we get jobs, right? But it's very hard to kind of push back against this. And of course, it's not up to everybody that is interested. Some people really just want to do the programming and not deal with these things. But we still do need people who are able to do both. And that requires, if I may be so proud, whatever, immodest to say, it requires rethinking our education in this discipline, or just really kind of engaging with this interdisciplinary training of people. And it shouldn't be the case that somebody should get a degree in moral philosophy or philosophy in order to be able to do basic argumentation and reasoning if they're going to do computer science. And vice versa, somebody shouldn't get a degree in computer science in order to be able to understand how machines work. So from our own disciplines, we need to create interfaces to other disciplines.
Great, thank you. We have one more question.
Okay, that one is easy. So in one of your slides, you mentioned that agents follow norms, not the machines. And I was like wondering, like, how do you define the difference between agents and machines?
That's a tricky question, and you know it. That's a trick question, and you know it.
Interchangeable, I guess.
We need more philosophers in the room for this one. So basically, if you start looking at what is the definition of an agent, is a thing that can act, is how we define it in computer science, but in philosophy, it kind of more is like, well, it has agency. So what does it mean to have agency? Well, it has autonomy. What does it mean to have autonomy? Well, it has agency, right?
It's the next problem of it.
Yeah, so, I mean, the thing is, what makes a difference between an agent and a software program? I think the difference, let's stick it very simply, it should be able to take input from the environment and exercise effects on the environment while with an intention to accomplish certain actions. So not just randomly doing things, but...
Okay, this is agent.
Yes.
And how about machine?
I define machine here as anything that is basically a computation, either runs the computation or, yeah, that's simple. I should have said that at the beginning.
Do we have any other questions? No? Nobody wants to know more about this softener? I mean, you have to tell me everything about it.
I don't know anything. I just went to the supermarket and I saw vegan softener and I said, oh my God, these vegans, they're trying to make everything vegan, it's softener. And then I looked it up and I realized it's made out of squished cows. So I'm like, okay, fine, vegans 1, Marija 0, but fight continues, right?
Well, yeah, I'm going to read up on that. Well, thank you very much. And thank you everyone for staying till the end. In the program, there was a wrap-up, so I'm wrapping up. Thank you. Have a nice day. Have a good weekend. Thank you.